Hmm. Hmm. Nathan, as we get ready to start here, I want to recognize, point out that there are at least, I think, two, and I'm looking around to see if I'm maybe missing. There are at least two students in the room who I'm guessing may not have registered, which is fine. It's no problem at all. But the fact that they're here to listen to this conversation just gives me a great deal of satisfaction, yeah, and hope that maybe we'll find the next person who somehow gets bit by this aviation weather bug and says, yeah, I want to learn more about this stuff.
All right, well, I'm going to go ahead and get started, and I'm going to turn it over to Godfrey, who's going to switch gears on us a little bit, start talking about aircraft dispatcher training. Obviously, pilot training is a huge focus, but there's this world called aircraft dispatch that is sort of, it's much smaller than the pilot world, but probably even more critical in terms of weather analysis and weather knowledge. So that's my background, and there's several in the room obviously that have that background. But Godfrey, you want to go ahead and step up and get started?
All right, good afternoon. Did we all have a good lunch? Good, good, good. So hopefully I don't put you to sleep after with that lunch on there. Cool. So I'm Godfrey D'Souza. I'm an assistant professor here at Embry-Riddle. Just a little bit about my background. So I got my dispatcher certificate through the program back in 2016 is when I officially got my certification. I did go ahead and was in the industry for about 3 years working as a dispatcher. Kind of came back here, and now I'm teaching the dispatch course. I'm also in charge program coordinator of the airline dispatch course over here at Embry-Riddle. Just want to give you my background and how I transitioned over here, put in the training that I got at the airlines and into the dispatch certification on here. Cool. So looking at today's agenda on there, we'll talk about the personal certification process that I went through, and also the industry experience gives you more of a background before we get into training over here at Embry-Riddle. Some of the challenges effective weather education for dispatchers, some of the challenges that I faced being on the line or being training as a dispatcher, and how that certification process kind of helped but didn't really help through it. Possible changes maybe that I would have incorporated or would have liked to see in the industry, and then how I've tailored them into our dispatch course over here at Embry-Riddle. So that's what we're looking at. So first things first, going through the process, I did start off here at Embry-Riddle in 2011. Took the dispatch course back in 2014, so I was 21 at the time. So as all of you are familiar with, being 21, you get to take the practical, but not get the certificate until you're 23. So big gap in between. So I wanted to focus on that a little more. Looking at the course outline, the way we have it structured here at Embry-Riddle, usually we support a lot of the pilots who pick it up as a background, just in case they lose their medicals. That's our tailored audience that we have here. We do have also the air traffic majors that come in, probably some meteorologists too, and a little bit of, haven't really seen engineers or anything like that, but we're really structured on the courses that we have. So in order to take the final dispatch certification course, you do need to take a bunch of background courses. Two of them being the most important ones, you're looking at WX201, which is Survey in Meteorology, and WX 301, which is Aviation Weather for Pilots on there. The way you take those courses, it's usually your sophomore year. So even before you get into the airline dispatch operations course, which is our 400 level course, you're a senior already about to graduate. So the first thing I see right there is a huge gap in between. You kind of take that course, you forget. I'll be attested to that. That knowledge wasn't really too good of a weather person. You kind of make it through, and then you take the dispatch course. And the problem with the dispatch course is there's so much information that we need to press forward to you. You're looking at regulations, flight planning, MEL, CDLs, a huge, vast amount of information before you can even take the check ride on there. So at least for my course, we presume that you've completed all the weather training, you're proficient with it, and we move forward with it. So a little gap right there with the knowledge. Further down the line, going through it, another gap I see is being 21, getting your practical done, then finally getting your certificate at 23, and then possibly applying to the airlines. So there's a gap right there with the knowledge entailed as well. Looking at it, I did go ahead and enroll into the master's program before I went to the airlines. So I got hired at the airlines in 2020 is when I did go in. Looking back at it, the weather information was still kind of iffy on my side. Basically, you get into the airline world. And once again, this is my personal experience on how I went through it. Looking at it, we went into ground school training, which is in-dock training that we had on there. Basic weather information, you kind of look into METARs, TAF, the forecast charts, really quick run through to go through the whole process to get you on the line as quick as possible. Then going on the line training with another dispatcher, at least for the regional world, you have the new trainers that come on the line, pretty much cycling through on there. So minimal experience, if you will. Trying to get through the training, you're learning to use software, learning how to communicate with the pilots, learning how to do your flight planning, et cetera, et cetera. The key thing that didn't really click or move forward was the trends in weather, which we did talk about earlier on here. Looking at the specific patterns, I learned that being on the line as a dispatcher. So that was kind of scary. I think all of us have, at least our dispatchers, have got ourselves caught in the cookie jar with that one airport falling below alternate minimums en route, and now you have to amend your dispatch release and put in an alternate on there. So we have to learn it the hard way, but that's one of the examples that I had right there. Apart from that, I did like the summer recurrent training and winter recurrent training that we do have at the airlines. It really focuses on the patterns that we have. So summertime, everyone's familiar with the pop-up thunderstorms on there. Really train you into how you go ahead, deal with that, fuel calculations, looking at the weather trends on there. Starts off great in the morning. As afternoon rolls around, the next shift comes around. Oh man, we have a bunch of thunderstorms going through the area. Works the same way with wintertime operations, where we were really trained, looking at specific icing conditions, whether airports falling below minimums on there, and looking at field condition NOTAMs on there. If there was one thing I would like to go back in the airlines and train more, was probably field condition NOTAMs. If dispatchers are pretty familiar with planning with specific conditions on runways, so your FICON NOTAMs on there, that was probably the hardest thing to incorporate or entail on there, and trying to figure out your performance calculations. So that's something I would have taken a look at a little more. Good. Moving forward with some of the other challenges that we had on there, I think the one thing with the dispatch world is you have so many different backgrounds that come in. At least when I worked at the airlines, we had former nurses that worked there, former air fuel refuelers. You're looking at ATC majors, pilots, of course, and crew schedulers that all got into the aviation bug and now are dispatchers on there. So that kind of disconnect, not having enough background with weather training on there, that kind of inhibited being a dispatcher on that side. Well, basic weather to get through training with all the programs that we have on there. Once again, I don't want to repeat myself, but looking at that disconnect between getting your practical done at 21 versus getting your certificate and actually getting on the line, being dispatcher on the job, that kind of disconnect is a little bit a problem, I would say, a challenge on there. Minimal training in ground school or on-job training. Looking at it again, the new trainers. So I was a trainer as well, being a dispatcher. One of the hardest thing is training the different backgrounds that you have on there. You really need to have some kind of solid foundation before you become a dispatcher, looking at the weather pattern specifically. You're planning your flight around weather. Really need to take a look at how we go along with it. Cool. And then, like I said, with the self-taught weather trends and safety measures, one thing we look at with the airlines, at least, legality versus safety measures on there. That's where you have the fine balance that we kind of have to figure out ourselves. So being on the line, that's what really entails your legality versus safety measures on there. So the one example I like to give is the way I, on the line, got caught on this is I had a flight en route, new fresh dispatcher, first week on the job, flight took off, the destination airport fell below the alternate minimums, and then I was struggling, panicking on what to do. Now I needed to go ahead and amend my dispatch release to throw an alternate on there. If I would have learned the specific patterns that we have, maybe that would have saved me on there. Another thing that was a big factor was probably the icing conditions too during the winter time. For our company, we did resort out to WSI Fusion, which did give us icing forecast. As a dispatcher, I was always concerned about looking at icing charts. I did look at icing charts. If I knew that there was icing en route, I would still kind of rely on the experts on there to give me that support. So just having more of that confidence and knowledge that might have been, a little more useful. Cool. Probably some of the changes to improve weather training, at least from the dispatch side. So I'll go over it through the airline dispatch course and then finally to the airlines on what I would like to see. Use of weather software in certification and training. We're all familiar with, if you're taking the dispatch course, we don't use any software per se. We always have to do everything on paper. That's according to the PTS that we have right there. I would really like to incorporate some kind of weather software. The challenges we face is we look at more static weather when we're planning our flights or teaching the dispatch course versus real-time weather, specific trends, and it keeps going on and on. Some of the refresher courses, it would be great if the FAA would provide some kind of refresher course, at least for like dispatchers while we're waiting between the 21 and 23 phase right there. Maybe do some kind of online refresher course, have some kind of in-person workshops, something like that. Another thing is dedicated ground weather training sessions in the company. We really didn't have that in our company. Dedicated ground training sessions just on weather. Maybe take a couple of days to sit in, talk about weather, do like a basic review, refresher course, something like that. And then maybe looking at some kind of meteorologist, educators. WSI Fusion was our big contractor that we have on there. Actually have them come into the airlines and give us like a week course on some kind of workshop or something like that for the dispatch on their side. Some of the changes that I've made specifically to our dispatch training at Embry-Riddle. So I've introduced a more structured way of looking at weather. When I took the course, all the weather was given to us by our former instructor. So the way I have them do it is actually pull out weather when they do come in to get their practical sign-off on there. So they go ahead, pull out all the information, and we break it down into looking at origin, destination, and route, further bringing it down with big picture to small picture on there, looking at your specific charts, and one more thing that I have right there is planning legality versus safety measures. I like to do my experiences over a dispatcher on the line, putting it in the classroom right there. The big thing, the game changer that we have currently with our dispatch training program is we do have the dispatch course where you get your certificate, and then the students also are able to take a core requisite course, which is our airline ops command and control course. What that does is you learn how to be dispatch certified in the course. And now in the airline ops command and control course, you actually put that into practice. So what you do is we teach them how to use industry standard software. So that's where the game changer comes in. We teach them how to use WSI Fusion in the lab, if we will, and use NavBlue, which is another source of weather that we can get on there. So that teaches them looking at real-time weather to specific weather trends as well. We do also use scenario-based training. So what you're looking at that is we'll run lab sessions on there. Talking about weather specifically, we have two scenarios where you have an airplane en route, looking at that drop in the destination and now helping them change it. Oh, maybe we should have caught this before dispatching the flight, taking a look at that specific trends on there. So that's another option. And we do also have some kind of icing conditions as well. So we run these live scenarios on there, really making the students think outside the box than just looking at static images. And then the last one, looking at future training goals on what I would like to see on there, is pretty much trying to rework the PTS, if you will, and incorporating software, looking at real-time weather, not just static images on there, and possibly having more of a weather, so increasing the weather side on the PTS where we test them more on ongoing weather changes. So looking at that, I will pass it over to my coworker, Victor Fraticelli, who will talk about more about the dispatch course and how we do our practical exercises, look at weather, but I'll leave it open to any questions that you may possibly have or suggestions on how we would like to change our dispatch course.
So there's time for questions. Anybody online have any questions for Godfrey?
Godfrey, you probably said this at the beginning and I wasn't paying attention. If so, I apologize. But PTS stands for what, please?
Practical test standards, practical testing standards.
Thank you. Okay. Clearly I was asleep when he said that at the beginning.
So would you say that you have a majority in your classes that are actually not pursuing dispatch as a career, but it's just sort of a collateral? I want to get the license just so I have it.
It's usually a lot of pilots that come in. We have a handful that maybe go out into the industry. So far since I've been here, we have only 4 that actually are in the industry right now.
You said something at the beginning that I wasn't quite clear on. There was like a disconnect with like the way the courses were sequenced, where
Okay.
someone would get certain higher level courses before they had the requisite knowledge. Can you explain that again?
Yeah, so the way it's tailored out with our dispatch program is you take at least 4 or 5 prereq courses. So you have your performance, you have your aerodynamics, your navigation, the 2 weather courses, and an ATC course. You take them throughout your college career. So usually you take the weather courses kind of in the sophomore year. You're looking at a sophomore, junior year. And finally, right about before you're supposed to graduate, you take the dispatch course. So it'd be like a year or so before you can even get to the dispatch course on there.
Okay, so you're getting all the theory
Mhm.
and then waiting another 2 years to actually get sort of a real world application
Exactly.
course. That's interesting.
Exactly. And there you have the disconnect right there, because when you take the 410 dispatch course, we're teaching you pretty much trying to get you set up for the practical exam.
Right.
So we assume that you've got all the prerequisite knowledge and you're well set, ready to go.
Interesting. Is there any thought of changing that course structure?
The course structure, in order to meet the 200 hours on there, we can't really change that, especially being a university. We kind of are dabbling into a summer type course. It's just hard to get all those courses lined up over the summer to where we can meet the 200 hours and get the sign off to take the check ride on there.
Yeah, I heard a common theme here about this whole age 23 thing, and maybe there's maybe some FAA folks online who can provide some background on that. I don't really know where all that started. I'm just naive on that. Well, I mean, you can get a pilot's license much younger than 23. So why do you have to wait till 23 to become a dispatcher? Has never made any sense to me whatsoever. But maybe that's maybe that's an impediment to better weather training for dispatchers, is that some of them are getting their training before they're even allowed to get a license. And so there's this big gap. That's not something I even thought about until you mentioned it. So maybe it's something to flesh out in the future as we go through this discussion.
Matt Tucker? Hold up your hand, Matt, so Christian can see you.
Yeah, I was kind of looking that up because I was 17 when I took my CTO exam and had my first tower rating at 18. So it just boggles my mind that you have to be 23, and yet I had a CTO for 5 years by that point. So
correct me if I'm wrong, but don't you get the ATP as well once you're 23? So I think it aligns with that on there.
Okay, it's probably has something to do with that. Yeah, because you take the same test as an ATP.
Yeah.
But obviously it's not the same job. So
Right.
You know, Godfrey, I'm I'm sitting here thinking about the comment that you made about you know, only a limited number of students had made their way into the Part 121 or 135 world as dispatchers after leaving the school. Yet you have, I would presume, some significantly larger number of students that have taken the course, many or perhaps most of whom are or were in the process of becoming pilots. And I'm just wondering to myself, since as a former Part 121 dispatcher, I have this notion of the role that I played in the decision-making that went on with respect to operational control of a flight, and the fact that a GA pilot is basically a dispatcher and a pilot all wrapped up into one. I'm wondering to myself if you've queried your students who have gone on to become pilots, perhaps GA pilots, perhaps even business aviation pilots, that don't necessarily have a Part 121 dispatcher on the ground watching them. I wonder if they felt like what they learned or got was beneficial to them in being able to successfully and safely operate their aircraft.
Oh, definitely. The one thing I do tell them to take on if they go through, you know, the GA side or anything like that, we learn a lot coming over. You have a bunch of background courses that you take that does build up your knowledge. Looking at the regulations as well, some of them do kind of mirror each other on there, at least for pilots. And I can say this for pilots going to the 121 side, they do take all that knowledge. So when they're in dock training, it's like, oh, we know this, we learned this. CO 55, your alternate minimums right there, they're already familiar with it. So they know it once they go out on the line. And I do have a lot of them regretting not taking the certificate. I will say this though, at least for us, the problem is being a senior and you're graduating. You're trying to look for a job. You're trying to get your graduation done. You're trying to leave. That 90 days to take the practical exam, it's a lot, I will say, for the students on their side to kind of just go through it, go through the motions.
okay. Thank you, Godfrey. Very informative. And like you said, tomorrow your colleague will be giving some more specifics about some of the things you do in the classroom. So I'm going to go ahead and turn it over to Mike Splitt for our next presentation.
Does it aim at that? Or do I need to, am I missing something? Of course. What do I need to do? Do I need to go? Oh, there we go. Did you do that? No. I'll need control though. Will that happen?
Yeah, you should have.
Okay, fair enough. I'm Mike Splitt, College of Aeronautics Tech. I teach aviation meteorology 1 and 2, mostly there. So I have experience teaching meteorologists, aviation meteorologists, and a large set of aeronautical science, some of these majors with and without flight. And there we go. There's the title. I don't know if I'll be clearing the skies. That might be a little bit of fake news. But I'm going to be talking about many issues related to weather representativeness and that's a Trojan horse, let me tell you. Representativeness. This could be on an observational scale. Is this ASAW sensor representative of the weather nearby somewhere? So we can think of it that way. We could also say, I'm looking at this weather system, all these symbols on a map, and what would be the representative weather I would expect being in this part of the weather system. So I'm going to go over many different issues. So if you don't like one, just wait a few minutes, I'll be done and go to another one. So with some of the work with FAA Pegasus, we were initially doing a lot of work analyzing the Calabasas incident. And one of the mental models that we thought was really good is the idea, how do we make use of all these mesonaut observations? Because there are a lot out there. You get relative humidity, but how good a tool is that? Is the temperature dew point spread, does that really help you with, are we going to get fog or are we going to get a cloud? In fact, they call it the dew point, not the cloud point, right? So that's a challenge. How do you just throw all these observations, or can you leverage some other information? So the other information is, for example, we might have had the Van Nuys ceilings, and we're comparing it to the mesonaut observations. And as the ceilings at Van Nuys go up, we'll see that the relative humidity goes up at these once that cloud layer gets up to the station elevation. And what I'm showing here, these are box plots, box and whisker plots, but basically you're just seeing it's almost saturated by the time that cloud layer gets up there. So this was about leveraging mesonet data. You don't want to tell somebody 100% relative humidity, you definitely have to worry. It could just be dew. So we're trying to leverage another data source to give more confidence that mesonet information would be good. So this is about, if we don't have representative weather, what can we make out of these other data sources? So that was one aspect of the research that we were doing. Had a student working a couple of years now on using camera imagery. Again, is a pilot going to look at 5,000 different images of the weather? Maybe we could help identify cloud types. So Marcus Cote, who's now doing his doctoral work, is doing a really good job of doing many impactful cloud types. So those are some of the results there. We see them nicely matching a good chunk of the time. He's made many model improvements. And now we're getting to the point we're doing a pretty good job at identifying the clouds, but when do you make it advisory to people? So it turns out the students are going to be at the Sun and Fun showing people different images and saying, is this towering cumulus look impactful to you? And we want to tease out, do they think it's close enough? Is it too far away for them to worry about? So again, those weather camera images, what do they represent? Are they a threat to you or not? Other work we did was looking at the impact of how two weather stations compare to each other based on how similar the climate zones they are in. And I would say more generically, it could be the Köppen climate zone. It could be other geophysical things such as ecozones or physiographic zones. And that we found that the more climate zone systems that two stations shared, the more likely they were to have the same weather. So what lessons learned were climate zones matter. The other thing is two stations that are closest together might not be the ones that are most similar to each other. You might be more similar to somebody that's farther away from you. And so this kind of closeness kind of permeates the mental models of instruction. We tested some of this out with pilots. This was done at the FAA Test Center. We're going to do some follow-up studies, just basically asking them, can you guess the flight rule categories at a location such as A, B, or C? And they're pretty terrible at doing this, but I have to say most people are. It's very difficult unless you have some local knowledge that you could progress through this. And it turns out as we added more information, the results weren't any better. They, in fact, could get worse in terms of predicting what the flight category rule might be at a given location. So do they have mental models to help with this? So we're trying to push the use of climate zone information to help kind of give people better mental models. I guess the more disturbing part is the pilots were fairly confident in their wrong answers. I don't know if anybody's run across that. So then we could say, okay, we could tackle this from more technical perspective. So if that's students working on station clustering, can we cluster climate stations together? And that's an example of one at the top. We're also using neural networks to try to use climate zones to help predict what the flight rule category. So we're just taking an approach that's technical, but can we leverage that for training? So this is just an example of some of the clusters that we did get out of this. And you'll notice things that are clustered aren't necessarily the things that are the closest together. They kind of go, you can see them oriented in this kind of west-southwest to north-northeast, east-northeast direction. And this is in the Appalachians, and the topography is kind of driving this kind of clustering. But if you go to some of the materials that are out there for, go to airnav.gov and they give you, what's the next station nearby? Well, is that the best station to be looking at? Or should you be looking at the one that has better weather associated with it? I can say, what are you using this for? Are you trying to get a better alternate airport? Are you trying to get representative weather? And again, the answer is the closest one to you may not be representing what your weather is. Then we can talk about conceptual models. I get many of these type of what I call weather test fails. Students come into me after they've got an unsat on a question from an examiner, and occlusions is one of them. There's many topics, and they're usually not happy that they got an unsat. But when it comes to occlusions, this was a question, they failed on the type of occlusion. They didn't get the temperature rule right to give the cold occlusion versus the warm occlusion. And this tweaked me. And it's got, what weather do we expect? What's representative of an occlusion? And so the weather handbook has the traditional cold front occlusion based on the temperature rule, and the warm front occlusion based on the temperature rule. And this is in many basic meteorology courses, you'll have this similar kind of stuff. Fine, but it's way out of date. Yes, the rules have changed. The temperature rule doesn't do a good prediction of how the air is going to go up the boundary. Is it going to be forward tilting cold front, backward tilting cold front? We've gone to static stability, and you're like, oh, wow, we have enough trouble teaching them temperature rules. Are we going to have to talk about static stability? But here's the question. The temperature rule's horrible. It doesn't do a good job of predicting the type of occlusion. So what, and then we're going to give somebody an unsat on a test on knowledge that's out of date. But that's where we are, because it's easy to do the temperature rule. I guess the static stability rule would be really difficult. So I pulled this out of the literature, occluded fronts and the occlusion process, and just different tenets that we've kind of held for many years are just kind of thrown out the window. And I could list a bunch of those tenets right here. We just pull any one of them. Occlusion means that the cyclone will stop deepening. Well, it turns out that's not the case. So there's a whole bunch of these, and they permeate handbooks, not just the FAA, but basic weather training. And what's the end result? Are they better able to fly through occluded fronts based on what we're doing? Occluded fronts are associated with widespread clouds and precipitation followed by abrupt clearing after surface frontal passage. Reality. Occluded fronts are associated with a variety of cloud precipitation patterns, including dry slots and banded precipitation. So what are we trying to get them to know is outdated theory when things have advanced. So I think we have some updating to do. It's very hard to read up there, some of what I call weather on the streets, but I love going to pilot forums. If I can't get stuff for my students, I go to the pilot forums and see what they're talking about. And you'll see some of these same kind of issues they're having with these kind of weather representations. So in the classroom, I'll talk more about this tomorrow. We do some intense data analysis in the Aviation Meteorology 2 class where I have more freedom to do some more discovery. the aeronautical science students, which is the majority of students, do airport-based projects. And one thing is, what does gustiness represent? And the interesting thing is, it depends on what gustiness you're talking about. So if we talk about aviation gust factor, we're talking about a subtraction, the gust versus the average wind. But in meteorology, when we're talking about like surface roughness, we do a ratio. And so they do analysis based on the 1 minute ASOS. And we'll get plots like this for the aviation gust factor. This is Albuquerque, and you'll see this very high gustiness from the easterly direction. Anybody fly into that area and familiar with why we might be getting gustiness from that direction? There's the Met gust factor. So they're both gustiness, but you'll see where it's high is totally different. They're totally different stories. So what I talked to them about is that the aviation gust factor is driven by bigger weather events, and then the Met gust factor, which will tell you more about the localized mechanical turbulence. It's not always so crystal clear, but I'll just show you. Yeah, if we look at the top topography of where the airport is, there's canyons and there's gaps in there, and that drives some of that big aviation gust factor. What's going on locally? Yeah, we've got a lot of gustiness coming from the southeast or southwest direction because of all the terminal buildings and such. So that's an example out of Albuquerque. Let's go to Dallas. Here's the aviation gust factor. You'll notice with northwest flow, we get a lot of action there, and out of the south, there's a lot of action there as well, driven by probably meteorology of frontal systems. But let's look at that Met gust factor. Gee, they don't have a canyon to the east, do they? Nobody's flown into Dallas, apparently. Okay, well, there's Dallas. Not too interesting topo-wise, but let's look what's going on at the airport. And there's the ASOS, and if you look just to the east, you'll see this building over there. What is that building? Oh, it's that thing. So, yes, we're picking up the tower. In the meteorology observations, the students kind of like seeing this. We could talk about surface roughness, but here we go and show you might have some localized effect and you can pick it up in the observations. And then, yes, these are supposed to be sited in a representative location at the airport that is well sited and doesn't have these effects, but it's challenging. There's so many structures at airports. We also do a lot of ceilings and visibility. For those who are not familiar with the West Coast June and gloom, you could see the statistics for flight rule categories by month. And you can see as we get, it's called June gloom, but here it's obviously getting worse in July and August. But it's that coastal stratus and fog that can move in the summertime. So one thing was interesting after teaching this for many years and going through hundreds of airports, you know, even me, something will kick in after a while. And I notice there is something in the Northeast that I'm calling murky May and not so bad November. It's not as dramatic as this, but I started noticing it's more subtle that you'll see there's a drop in the flight rule categories that are good, less green as we get into May. You would think we're going from spring to summer. We might naturally think we're getting to improved weather conditions, but there we are up at Boston. You can see that downward bump in May and then sort of this odd upward bump in November. So that's great discussion points. What's going on there? Is this the only place it's happening? No, it's happening here. It's happening here. It's happening here. It's happening here. It's happening there. It's happening there. Am I going to continue to do this? Yes, I'm going to continue to do this. And it's going to it happens there. Who would have thought that this was going on until you start looking and diving into the data and doing it at lots of places. So it's repeatable over a good chunk. Do we have good explanations for this? I have some conjecture at this point, but it's going to take a little bit of research to actually say, why are we getting this murky May and not so bad November? Again, in terms of training, what does that do for somebody? I'm trying to give them a more critical look at the data, right? Not just to take everything as is, treat it as perfect, to understand limitations, to understand different perspectives on the data itself. Hopefully this leads to better outcomes later, but I like getting them into the data, doing some data discovery, and these are some of the things that we're kind of discovering in that process and learning about, hopefully, representative weather in the process. Yes, I'm putting this on there. These are my opinions. It may not reflect people that fund me from the FAA or Florida Tech. And too bad weather wasn't as simple as these kind of old cartoonish images that I love. But I'll open up some, I know I talked a lot of different things in this short period of time, but I'll open up to some questions if you have any.
Questions for Mike?
So you cracked the door open. You said you had conjecture. What are you conjecturing?
On the murky May. Okay, let's go back. Murky May. And feel free to add your own conjecture. We don't have this nice coastal fog comes in theory, right? So what might be going on in May? Are we just getting more active frontal zones in the region that overall in the Northeast? Is it advection of the moisture that's kicking in? So this would definitely take some more analysis, but it's definitely repeatable. It can't be completely random. So is it just the driving weather pattern in May? What's the ground hasn't warmed up yet? We're getting more moisture in, not sure. November, are we just getting high pressures to start coming in? Is it we're getting the frontal systems back down south in October, and then now the high pressures are driving far enough south to bring in more of those clear high pressure days in? Is that what's going on in November? Not sure. But wouldn't you want to know that it's not just this nice little curve, if it's improving as we go into the summer, worsening as we go into winter? We have these anomalous months that break the pattern.
It looks to my eyeball like all these stations you've ID'd with the murky May, nice, not so bad November are east of the Appalachians.
Yeah, now I haven't, yeah, so as I go into the Midwest, I lose this pattern. As I go south, I lose this pattern. So, and I haven't done them all, but this was a collection over the past few semesters that I picked students' results and just threw them up there. So it's definitely a Northeast phenomena into the Appalachians. You can see, right. So what's going on in particular that's helping drive that? Like I said, there's conjecture, but there's going to be a lot more data analysis, but it does drive questions, right? When you actually look at the data. Oh, go ahead. Hot mic.
We do have some questions online. Tom George says, have you tried making use of FAA weather cameras to evaluate the representative nature of an AWOS observation?
So the work Marcus is doing is a mix of weather camera imagery from the FAA. We're working with MIT Lincoln Lab. In fact, they're wanting us to send us our cloud type estimates to help them with the ceiling aspect, because they're trying to get beyond the visibility to get an accurate ceiling. So we are working with them. We are using FAA camera imagery as well as data we've collected from the alert fire weather out west, and you know, we have a lot of thunderstorm imagery from Melbourne area. So we are using FAA sources.
Randy Bass asks, Mike, how many years of data have you looked at to make those graphs?
These are on the order of 15 years of ASOS data at these locations. I think this year I'm doing, some of them have 20 years of data. So they're not just like a single season.
Okay, and Mike Graff from the National Weather Service just offered a comment. He says, we do 5-minute TAF versus METAR for every TAF in the US. If you get some questions or need some data we can provide, just let us know. We go back to about 2007-ish.
Thank you.
Not sure what he means by 5 minutes. Oh, 5 minute TAF versus 5 minute. Okay, 5 minute ASOS.
So
Thanks,
what's
Mike.
oh wait, I have to say, what is the 5-minute TAF?
Well, they evaluate the tasks on 5 minute intervals.
Okay.
That's what it sounds like. Mike, feel free to chime in. You can unmute if you'd like to say something.
Oh, you're correct, Nathan. It's we're checking the METAR against the TAF every 5 minutes. We do about I want to say maybe 620, 650 TAFs in the lower 48. So it's not perfect, but it would give you something. And we're just putting the offer out there. It only takes a second to run the data. So just let us know if you have any questions or are interested. That's all.
Thanks, Mike. Oh, looks like we have another question here. Just a minute. Kevin Kronfeld, I think is your name. What kind of accuracy are you getting with the ML cloud classification?
So the validation training is the validation part of the system is at about 98%, but I wouldn't say that's necessarily what you're going to see on the street. We've done a lot of effort to identify the correct cloud types. We went to some databases that were out there, actually published, that were not so good. You'd look at the what they call the nimbostratus and you'd be scratching your head. So we put a lot of effort into properly tagged images, and that took a long time. So we do, but you're not capturing everything when you're doing this. So like I said, we're getting 98% for those many categories, but we're going to still see it's going to be less than that when you have it work, like I say, in operational setting. And there's still challenges with mixed cloud types, right? We went with the model of what is the predominant aviation hazard in that image as the context. And those choices you make on machine learning are important to your whole model that you have.
Yeah,
the choices you make. So
I'm fascinated by, the use of the advanced sort of a data analytics in the classroom. I know you've talked about some of your students and their reaction to doing, some pretty intense data analysis using code that you've written. I'm just wondering, the reactions that you've gotten with this kind of analysis and just the use of climatology in general in the classroom. You find that that's is eye-opening for your students once they get over the hump of the technical nature of this work?
Yeah, I think it does help. I mean, they have some interesting discussions. It's, they're at first like, why are we running programs? Complaint. And of course I have to deal with IT at times because that can be challenging. But I think they learn stuff. The funny thing, the pilots don't know much about what's happening at the airport. And so some of like the local, why are we getting roughness from this direction? Well, they don't even look to see that where are these buildings and stuff like that. So it's kind of interesting to have them dive in and look at all the objects that are around the airport. Sometimes we have interference from the instrumentation that is the glide slope instrumentation is right near the ASOS typically. And sometimes those have towers on them. And we've noticed like when the wind's coming from that direction, not 30 feet away, they're getting turbulence from that. So it's kind of a learning experience for them. And, I'm not doing this to diss the data, but to make them feel a little less certain to think about things and not just take things at face value. So I think that's an important lesson.
Yeah, that's absolutely. And that's, again, it goes to the whole theme that we've heard a lot today about really applying theory to real world experience. So thank you. We're going to take a break now for about, we got some more questions. Well, yeah, go ahead.
Just one more. Matt Tucker, have you looked at the difference between a automated report on an ASOS and an augmented report, which means a controller or a weather observer augmented the weather? I know on the ATC side, that doesn't happen as much because it's such a low priority as far as work-wise. But do you see a difference in that?
So I've written programs to deal with 1 minute ASOS and the 5 minute METAR formatted data. I haven't ventured into, let's compare it to what actually comes out and might get modified. That's aggressive for me to deal with. I'm dealing with 70 posters this semester on different airports. It's challenging enough there, but I understand what you're saying is that what we're seeing in there might differ because somebody overrode something in the observation, but I'm not addressing that. That is an interesting point. I just have to say I'm surprised nobody has anything to say about occluded fronts, and apparently it's a scary subject area.
Who's the examiner asking about occlusions on a practical test? I don't want to meet that person.
Yes, and I've had students complain about getting Hadley cell questions as well. Which, you know, I'm like, well, we don't have a SIGMET for the Hadley cell, but so it makes me, you know, but things happen out there. It's the Wild West when it comes to examining, as far as I'm concerned. So
Yeah, that Hadley cell will get you every time.
it does.
Gus, did you have your hand up? Okay, sorry.
I just have one, Christian Amaral, I just have one question about ASOS and AWOS. I think of those as kind of like the gold standard of weather observing tools out there. And then we talk about, you know, having weather cameras, or Matt mentioned weather observers. I can think of a time recently where we're going into Hayden, Colorado, and conditions were not at all what the TAF was indicating or what even the AWOS was indicating when we were fairly close and could get reception. So is there a big difference between those two things? And is there potential for improvement with weather cameras and observers?
So the value in weather cameras to me is often they are places where we don't have weather stations. So where are typical airports? In valleys. So, you know, interesting, you could have an Appalachian fog event and all the valleys are socked in white strips from the satellite imagery, but then all the ridges are nice and clear. So just to say that things could be different based on your geographic location. And we tend to have METAR, ASOS, you know, these are all typically valley locations. So the weather cameras are giving you in between stuff that is really helpful. It also helps fill in, I mean, you know, for Alaska, it's helping fill the data void in many areas there. But, you know, it's weather information places that we don't have representative observations. We don't have a ceilings and visibility. We don't have LIDARs everywhere, but we can perhaps utilize these other resources in these in-between spots. The en route, which is impactful, especially for low altitude operations, some of these observations. At least that's my perspective.
Okay, so we're gonna go ahead and take our break now. I actually remembered the break this time. And then, so Mike, our final presenter, Michael Dornick, you are online, and we'll probably start here at about, let's do 12:50, I'm sorry, 1:50 local time. into your teams there, you can, share your presentation.
And by the way, Nathan, Michael and Stephen and I dry ran his yesterday.
Oh, that's right.
So he's
Yeah.
all over it.
Got it. Oh, okay. So Michael, this is Nathan. I think we're ready to get started with your presentation. So sounds like you did a dry run yesterday. So we'll give it over to you.
All right. So can everybody hear me okay?
Yes.
Okay. So let me go ahead and share my screen. Include sound. All right. So are people seeing the full slide?
Yes.
Yes.
Okay. All right. So thank you for inviting me to come to this. I was able to catch a lot of the talks in the morning before lunch, and they were just fantastic. And so it's really nice to see all the work that people are doing, and hopefully our work can slot in there somewhere. I'll introduce myself. My name is Michael Dornike. I'm a professor here at Iowa State University. I actually spent 13 years in advanced technology at Honeywell before coming to the university here in 2012. So my career is now sort of evenly split between doing research in industry and doing research at the university. And I'm going to talk today about applying some ideas around extended reality, augmented reality to aviation weather training. So I'm representing a team here. So Dr. Elliot Weiner, he's our XR expert. And then we have Jeff Whitehurst and Dr. Lori Brown. They are at Western Michigan, and they are flight instructors, professors who teach a lot of aviation weather. And so they're really the ones who make sure that we're addressing the domain's problems. And then we have a plethora of graduate students, some who have graduated and some who are still working on the project, and then a whole army of undergrad research assistants. Also want to acknowledge the Pegasus Center. This is focused on general aviation, and it's a grant with the FAA. And Gary Picodner and Ian Johnson are our technical points of contact. So I'll talk a little bit about the problem that we're addressing, and then really I want to take two perspectives. How can we apply augmented reality weather training for students? But then we also want to think about the instructor side. How can we make it easy for instructors to use this kind of technology? Because without looking at both sides, then there's a real issue with, is this something that could actually get out there and be used? I probably don't need to tell everybody here that there's a lot of challenges to enhancing weather education. So weather education takes training and assessment. Research has shown that students tend to think in 2D and think the atmosphere is fairly stable. And so translating a lot of the kinds of materials that we give them, which are, illustrations, text, things like that, 2D images into 3D mental imagery is difficult for anyone. There are other advanced technologies out there. There are simulators out there, everything from desks to high fidelity simulators, but those aren't available to everyone, especially in the GA world. And so there's an issue of accessibility if we're talking about some advanced technologies applied to something like weather education. Some of the challenges of current weather education, we heard a lot about this this morning. And really, if I were to summarize this, it's about how do we provide for pilots, especially early aviation students who are still in the classroom, how do we provide them the opportunity to experience weather patterns and all the complexity of weather and the dynamism of weather without, needing to basically hunt down bad or marginal weather in the air. And a lot of the education tends to be about weather knowledge. And so, you can learn about, the different knowledge and take the test and prepare for those kind of things. But how do you then actually apply it once you're up in the air? And so there's a lot of issues out there like lack of situation awareness if you're moving towards IMC conditions. Students have consistently said that they perceive that they have a lack of skills for dealing with that situation in particular. And again, this ability to correlate, interpret, and apply weather information in real life. And so students who are just coming out of aviation schools report that they feel not quite prepared to deal with real life weather. And so that led us to this initial project where we were looking at, well, could augmented reality provide some of that experiential learning? And so this work really draws on 3 different areas that we're trying to combine, and it's kind of represented by the people working on the project. So we have weather training. So, you know, what kind of weather training do we want to look at? And so we decided to focus on thunderstorms because that's a consistent cause of accidents and incorporates a lot of the kind of weather things that we were interested in teaching. And then we looked at augmented reality. Augmented reality provides the opportunity for things like immersion, animation, interactivity, the real world registration, which means that I can actually create a model right there on my desk, you know, right by the textbook or something like that. I don't need to go to another tool or anything like that. And then instructional design, you know, we can design well thought out learning modules or not so well thought out. And so, you know, what are our learning goals? What is appropriate for this kind of approach and what's maybe not as appropriate? And what kind of experiences and scaffolding and feedback do we need to provide? And so when we think about AR, augmented reality, and for those that may be a little less familiar, this is the idea that I'm going to create some digital content in the real world. And so it's not virtual reality where everything, you know, you're putting a headset on and everything is virtual. It's more like you're looking through your phone, or you could potentially have a headset where there's some pass through and you can see the real world. And then I'm adding some digital content to that. And so we wanted to create AR-based experiences to enhance the learning, the weather training learning. And so that immersion allows students to experience 3D AR weather models in their local environment. The animation helps students visualize the movements and the dynamic processes. But we wanted some interactivity so students could have a level of control as they seek out different kinds of information. And then I want those experiences concurrent with the kind of training materials they have now, which are often textbooks and things like that. So there'll be some animations here going on. I think we'll be interrupted by a little bit of lightning as well, but this gives you kind of an idea of what we've put together. And so this is simply the thunderstorm life cycle model, and it animates the different stages, the developing, mature, and dissipation stages. And this allows us to add things like the visual cues related to clouds. You know, how do these clouds grow? What do they look like? We can add cues to it, things like the winds and hazards and icing. You'll see it down the side. There's a lot of different filters. And so we can use different kinds of color coding and things like that to allow students to explore things like precipitation and temperature, winds, and icing. We also created a module around microbursts. So what is a microburst and visualizes that weather pattern. Now, this is one example of a wide range. One thing we heard very clearly from our aviation partners is that you know, there's no one typical kind of thunderstorm. There's no one typical kind of microburst. So, you know, we're creating kind of an example here. And we're looking at the developing and impact and dissipation stages. And again, we're using some visual cues, some labels, things like the virga and the dust ring, and labels for things like wind intensity and so on. So once we have something like that, now we want to start putting information together, right? So let's see if we can get this to play. Yep. So now we're going to visualize the 4 stages of if you're flying through a microburst, where in stage 1, the plane encounters a tailwind and or a headwind, and it increases performance. In stage 2, then you get a downdraft and that decreases performance. And then stage 3, there's a tailwind. Now it's further decreased performance. And you get to stage 4 where you're through the microburst, but now you have a dangerously low airspeed. And so we can step students through these and visualize those different stages. We can also put scenarios together where we create a developing situation. There's a thunderstorm near an airport, and you're trying to make a decision on whether you land at that airport or do a diversion. And so we can stop the scenario at certain points and ask questions and say, well, what would you do at this point in the scenario? And so we have several different learning experiences. And so initially we ask students to read the flight and the weather information, and then they can view this situation. So they have some context, and they need to correlate that written information, things like METARs and TAFs and different kinds of weather information with the developing situation. And then if it's a scenario-based rather than an exploratory kind of learning module, then we might ask them to make a decision at some point. And then we can show them, okay, here are the results of the decision you made. We often used use cases from real accidents, and also read the response of an experienced pilot. And we allow the student then to compare what was their response to the real pilot's response, whether they made a correct decision or an incorrect decision. I'm going to play a little video here where...
Traditionally, students use text and schematics.
Oops.
Traditionally.
Sorry. I'm going to play a little video here from Stephen Meister, now Dr. Stephen Meister, who ran some of the early experiments on these modules.
Traditionally, students use text and schematics to learn about the cell cycle. The representation is limited. It is two-dimensional and does not change over time. As part of an ongoing effort to develop AR-enhanced general aviation weather-related training, we have developed a model that represents the thunderstorm cell cycle in three-dimensional space and over time. Here, we will launch the model in a smartphone application called Weather Explore. The user opens the application and scans the AR marker. The weather model is generated above the marker as an interactive object in the real-world environment. Here is one 60-minute cycle at 120 times speed with precipitation. The model visualizes the cloud, precipitation, lightning, and thunder. Additionally, the model can visualize winds, temperatures, and icing. A different view helps the student learn about the cell movement across the ground.
So that gives you an idea of how to put all this stuff together. And I talked briefly about accessibility. Well, a lot of people have phones, and so a system like this is something that should be fairly accessible to most students. So of course, we wanted to test, is this effective? And there's a lot of different ways to think about what effectiveness means here. So the very first question is, do they learn anything from these modules by themselves? And so we had 18 participants. These were low flight hour pilots. And we see that, they already had flight hours. They were on the average 100 hours. So they came in with a fair amount of knowledge, but they still improved by using this system. And we could see some of the visual knowledge were even more greatly increased. And the questions that we were asking before and after all came from the FAA exam, or were at least based on the kinds of questions that get asked. We did another study further along in the project where we've answered the question, does the module actually induce some learning? And it does. But is it any better than traditional print materials? And so we really wanted to take the best of the print materials and the best versions of our scenarios and compare them to see, is there any kind of difference? Is there any kind of impact? So we ran this with 52 early pilots. On average, they had about 50 flight hours. And what we were comparing was not just the scenarios themselves, but embedded in a learning experience, right? So it's as if they're in a classroom and they go through the learning objectives, they read some text, and then they do activities. And those activities, the ones in yellow, are either in print, so they might have things like pictures and diagrams and things like that, or if they're in green, they would be in these AR 3D learning experiences. And so we're really trying to compare kind of the best version of each in the context of how they might be used. And so, there's lots of results. In the interest of time, I'll just try to summarize some of the more important ones. And so one of the things that is always shown with AR and XR and VR is that the motivation levels and the engagement levels are usually increased. And so students spend more time in virtual reality than they would otherwise. It really helps hold attention and can make the whole process a little more interesting, and students more engaged students are more inquisitive students. The learning effectiveness of the interactive training group was marginally significantly higher. So it was higher, but the significance level was under 0.1. And then both groups increased in factual knowledge. So we're replicating that early thing to say that both the print and the interactive print increased knowledge. One of the more interesting results of this was, we gave them actually 7 different learning experiences. And the first 5 were really based on knowledge. And so we might ask them to go explore the thunderstorm and answer some questions based on that, or some knowledge questions based on their learning about how a thunderstorm develops and how it dissipates and things like that. And so what we found was that in the knowledge-based activities, the AR, or the interactive print in gray here, was slightly better. And so both were effective to either 90% or 95%. What we had 2 scenarios at the end, which were more scenario-based experiences, where they were put in a situation, they got halfway through that situation, and then it was stopped and they had to make a decision. And what we actually found was that the performance in AR was lower. And so this was surprising to us. And so we went and explored, well, why was it lower? And what we found was that when these novice pilots learned in the print condition, so they were learning a lot of knowledge, and then they were asked these scenarios, they applied the knowledge that they learned. But what we found in the AR situation was that they started to rely on the visual cues. And so it's that classic thing of, I can see what I see in front of me and I can shoot that gap. And so, frankly, they were making some of the mistakes that novice pilots make the first few times they're up in the air, and they're trying to make these kinds of decisions, which they are not forced to make very often. And so this is a real learning opportunity. It provides the ability for students to make the kind of mistakes that they often make early in their flight experiences, except that they're on the ground. It's a lot safer. Right. And so this is an area that we really want to explore some more. So in summary, the AR content helps students visualize and comprehend the weather. We have these learning activities that, I didn't go into the whole instructional design, but there's a lot of that in there as well. It provides both exploratory and activity-based learning. So, getting more active learning and problem solving, kind of like what we were listening to this morning. And these experiential learning opportunities. And again, the accessibility makes this available to a lot of people without a huge investment. But we have to ask the question, who's going to develop these AR modules? We have a fleet of very smart graduate students who designed a lot of these modules, but that's not very practical for instructors. And so that really led to the second half of this work, where we wanted to figure out, how do we allow instructors to apply their domain knowledge to building these learning modules without having to become programmers. And so we did some interviews, we did some literature search, and what we find is that instructors were really motivated to create these lessons. They understand the engagement and motivation benefits. They like the idea of making abstract tangible and seeing the dynamism in weather, and the ability to personalize the training to either the students' needs or their needs as an instructor for what they want to teach. But there's been plenty of work out there to show that instructors feel like they have a limited digital proficiency. I think it was on the order of 94% felt that they had no knowledge or extremely limited knowledge in how to create these kind of systems. And quite frankly, instructors are busy. They don't have a lot of time to create these kind of modules. And so given that as the user group, the people who really want to use these, but they really don't have the skill set or training to develop them, that's the gap we're trying to fill. And so what we created was basically an authoring toolkit that allowed instructors to think in terms of flight plans and thunderstorms and airports, the objects of the domain that they're familiar with, rather than thinking about cutting planes and Unity and all the digital, AR kind of programming. And so, so we developed this software here, and this was based on requirements. We did a study with 17 aviation instructors to understand what kind of modules they would want to build. And then we created something where, if you remember that original phone app had a kind of a menu where you had filters, you could turn on and off filters for icing or temperature. So we allow the instructor to configure that menu. Maybe they don't want to provide all those options. They can pick predetermined terrains. And then in this window, this is where they're editing the scenario. And I'll put this all together in a video at the end. But they can drag objects like thunderstorms or microbursts or to basically create, and then they can preview. They can slide that slider down at the bottom to see what they're creating. And the box in the lower left, that's where they're adding details like how big is this thunderstorm, what direction is it moving, how fast is it moving, things like that. And then I can create a flight path. So I can have an airplane take off. I can have it fly as close to or as far away from these different weather phenomenon. And again, I add some details for each waypoint. And then I want to add some teaching elements. It's not just enough to show the scenario. I might want to overlay some text boxes that allow me to provide some instruction, like the 4 phases of the microburst. I might want to have some text. Or I might want to be able to put a quiz in the middle of the scenario. So stop the scenario, answer this question. And there are 3 potential answers, and then we tailor the response based on which answer the student chose. We also have a window where people can preview it, so they don't need to download the resulting file into their phone to look at it. They have this preview window. And I should say this is a desktop application, right? But the goal of this scenario is then to create a file that that I can download from this desktop application, and then I can upload it into the phone, into the app has been rebranded as Stormwise, and now the students all have access to this scenario. And so I think this is my video. Yep. And so we've sped up the video here, but you can see that we've already created a flight path. I can look at different angles here. I can kind of get the timing down that I want. I can add new elements and add some details. So here I've added another cloud. It's not a thunderstorm, it's just a cloud. And I can move it around. And so basically I have a nice interactive system that from multiple perspectives, I can build a scenario pretty quickly to do what I want. In the interest of time, I'm going to continue here, but let's see if I can. No, I can't go forward, but so, and then what I would show you is adding teaching elements and things like that. So we did another evaluation where we just wanted the effectiveness of the AR authoring tool from the perspective of the instructors. So we had 30 flight instructors, and we asked them to do 2 things. We gave them a scenario to build. So we told them what the learning objectives were. We told them what kind of scenario to build. But then the second scenario, we said, build anything you want. So we really kind of let them loose on the tool just to see what kind of range of things and could people effectively build something from the ground up. What we saw was that for that second scenario, that all 30 instructors built a range of different scenarios. So a lot of focus on decision-making, almost half, risk management, thunderstorm education, but there were some other topics like structural icing and cold fronts. And what we really saw from the instructor standpoint was a huge increase in confidence and familiarity with the process. They expressed a lot of concerns about technical complexity and mental effort and the time requirements. A lot of that was reduced after their experience. And they indicated high usability and a manageable level of workload. And probably most importantly, they were able to create from scratch, without any warning, a pretty effective module within about 17 minutes. And so that time aspect, I think, is really important. We asked them how they would use these things, and it was everything from part of a larger lesson or a standalone or group work, all the way down to some homework activities. And then finally, we did a study where we asked 3 experts who were experts in both weather education and flight instruction and artificial reality. So there are people like that out there, and we tracked them down. And we asked them based on a rubric to look at their assessment of the effectiveness of their use of AR. And what we found was that of the 30 modules, 29 scored higher than a 3 on all 6, and that last one was 5 out of 6. And so that gives us some confidence that we're creating something that is usable by instructors and produces good outputs. Just to wrap up here, from a student perspective, we're trying to enhance student weather training and providing early access to exploratory learning. From the instructor standpoint, the ability to either take an existing scenario and tweak it or create their own scenarios in a manageable way is all towards lowering the barriers to adopting these kind of technologies early in the classroom and enhancing weather training. And that's it. I think I have 3 seconds left.
Thank you, Michael.
Welcome.
Fascinating. I have a quick question about the Stormwise app. Is this
Sure.
something that's still sort of prototype? Where is it going to go from here? And what is the most advanced thing you can do in terms of simulation? Could you do an entire occluded front lesson in this particular tool using, what we talked about earlier?
So our project this year with the FAA is to get this out there. And so Stormwise is already on the Apple Store and the Android Store. I should have created a link for that or a QR code. And so there's some pre-canned scenarios in there, part of that earlier work, as well as the ability to upload one of these files, what we're calling Stormwise Creator, the authoring tool. That's probably still a few months from getting out there, but it's getting there. And so our idea is to create a little bit of infrastructure. What I'd ideally like to do is create a little community where people can upload, hey, I built this scenario, this might be useful for someone else. And then they can download it and tweak it for their purposes. And so that's about getting those tools out there, but also creating a little bit of scaffolding, some instructional videos and some, just a bit of where can you store these, how can you share these and things like that. So that's our goal, is to get this out there. On your second question, I will say this. I think we're doing a fairly good job on what we're doing, but it is pretty narrow, right? It's around thunderstorms. We've got some microburst and things like that, but it's not kind of a fully functional, every type of weather kind of thing. We'd love to get there, and we'd love to kind of transition to someone, a company or somebody who's really interested in fleshing out this idea to make it even that much more accessible. Because we would love to, see this out there and having an impact.
Yeah, I'm just thinking, like, you go to our Denver Flight Training Center at United Airlines and you see these gigantic multi-million-dollar full motion flight simulators,
Mm-hmm.
right? What's the equivalent of that for aviation weather training?
Yeah.
Yes, I know we're not going to necessarily spend millions of dollars, but why not, right? Can we produce a full motion weather simulator
Mm-hmm.
that brings it all together, and just takes what you're doing to the next level? I guess, yeah, we can all aspire to that maybe before we retire.
Yeah, the nice thing about AR is that you can actually walk around and look at it. It's basically, growing right out of your floor. And, yeah.
So Michael, could AR imagery or AR programming be embedded in a full motion flight simulator? So instead of just seeing out the window what the pilot sees with their eyeballs, they could see the process that's going on, causing what they see with their eyeballs.
Yeah, we are doing something with the FAA this year where we're looking at like a mixed simulator, right? Which is some physical simulator components and some AR components, especially that out the window. And we're trying to assess, again, where is that technology really provide value for training? If you're talking about something up in the air, actually, that's probably a little farther off. But the technology is there. It's really about, what's the most effective use of this technology to get the kind of training impacts that you want.
Yeah, I will say at United, I have talked to our instructor pilots in Denver, and they would love to be able to do that. It is it is very painful for them to create the infrastructure around a simulator event for the pilots, right? Because you get in there and everything that the airplane looks like and does is all there, but it's all the other stuff that supports that simulator session that is very hard to put together. It's very clunky and it's manual, and there's an opportunity there for somebody who wants to innovate.
Absolutely. And I've heard it several times, and I firmly believe that, one of our goals as instructors is to link that theory to practice.
Boy, that's a great way to.
That was the name of your I think it was.
A great way to wrap up what this whole session was. He just said it perfectly, from theory to practice.
Yeah. Yeah. I actually have one more question I want to explore, if it's okay with you, Nathan. Michael, you said you gave your experiment subjects the AR creation software and some, I presume, minimal amount of training, and then you invited them to build something, and they built stuff. And the number that you wrote up there made my eyeballs get really big, which was it was an average of 17 minutes to build one of these sessions. Did I remember that correctly?
Yeah, that's right. That was the average, and I don't think anything took more than about 20, 25.
So I'm now going to show my age, and I'm going to look at Brian Miskowski while I'm showing my age, and I'm going to say that back in the day, we used to say to one another that for an hour of effective training to either airline dispatchers or airline pilots, it took at least 8 hours of prep time. So there was an 8-to-1 ratio. Brian is nodding his head like, yep, that still is what we're doing today.
Yep. Yeah.
You can do this in 17 minutes. I think it kind of destroys that ratio at that point.
Well, okay. So to be fair, right, we asked them, that was 17 minutes to build the module. And then we didn't ask them to like build all the material around it. Like what are the assignments and all that kind of stuff. But we did ask them, what would you need to build around it? So that we had some idea, right? So our hope was that adding this AR part wasn't going to add another 8 hours to that 8 hour of prep time.
Well, I guess where I'm kind of going in my head is, would it subtract from it? Could it make that prep time a little bit less because of the power of the AI component that you're building?
It could, and part of the idea of creating a community to share these kind of scenarios is that people can share not only the scenarios, but some of the materials around it. Or maybe they're using, Lori Brown and Jeff have a textbook where they, where they have markers in there for our AR stuff. And so, looking for opportunities to integrate this seamlessly, I think is important. And the ability to create these, to share these, to customize these is kind of that, to make it as easy and smooth as possible for people to consider using something like this beyond what they're doing now.
Okay. Any other questions specifically for Michael? Well, that pretty much wraps up all of our formal presentations. So now it's really maybe the more informal part is to bring everybody back up, whoever's still here, from our presenters, to sort of follow up on some of the discussions that we've already had, ask them some additional questions. So if I could have Godfrey, Gus, Tom, Mike. I thought Beth was going to be back, but I'm not sure when she's going to be back.
And also EJAZ.
Oh yes, sorry. My apologies. We also have a couple of grad students, Scott's grad students, that are going to join us up here.
Scott says they are here.
We can get some more chairs.
Fully representing him, and they're much smarter than him too. Is I think
no,
what
we
he
got
said.
one more. We get one more chair. Okay.
Yes.
Okay, so for the folks online, you can see our esteemed panel auto assembling, and so from on your screen from left to right, Stephen, can you shove there you go. I knew you could do it. On your screen from left to right are Gus deAzevedo, Tom Guinn, Godfrey D'Souza, Alyssa Hayden. I want to call you Harden so bad. Ejaz Kadanoush, Mike Splitt, and Nathan Polderman. And I think it would be appropriate for Alyssa and Ejaz to just give us just a skosh of a here's who I am. You
I
know?
was going to say the same thing. Why don't you go?
Well, puny minds thinking alike.
Well, thank you very much for having us. My name is Ejaz Kadanoush, as you mentioned, and I'm a recently graduated undergrad here from Embry-Riddle. I graduated in December of 2024 with a bachelor's degree in aeronautical science and a minor with human factors psychology. And in May, I am beginning my master's in human factors itself. I graduated as an instrument-rated single and multi-engine commercial pilot, and I'm also a certified flight instructor as well, a new CFI. Yeah, that's pretty much my background.
Hi, I'm Melissa Hayden. I am also a graduate student. I am currently finishing up the first year of my master's program in human factors here at Embry-Riddle. I graduated from Arizona State University, with my bachelor's in aviation back in May of 2024. And so I have a lot of experience with kind of the aviation. I did management and operations was my concentration. So I kind of have more of that background and aspect of it. And currently I'm involved in some research here, both at the high altitude lab with some aerospace physiology with Scott Wagner, as well as with Dr. Beth Blickensderfer, who presented earlier, with her Applied Cognition and Training Science Lab.
For those who are online, are they seeing us in the front? Okay. Okay. Just wanted to make sure. So I've got a few questions that we could ask, but I'd like to maybe just start it off by allowing Jazz and Alyssa to give your recent graduate perspectives. Right? We've had a lot of students in the room, but we haven't heard from anyone that's kind of gone through this very, very recently. So based on what you've heard today, maybe you could just say a few words about your experience in getting trained as a pilot or as an instructor, the weather training part of that, areas where you saw a lot of weakness or opportunities for improvement. I think nothing is off the table, right? So I don't want to put you on the spot, but just give you an opportunity to maybe give us that perspective.
Yeah, of course. Well, first of all, I'll begin by saying, yeah, today was the first kind of, I guess, session of any kind like this that I've ever attended, and it was absolutely outstanding. I mean, I never thought ever that I would ever attend something like this, and through my studies at Embry-Riddle, I think I've come to learn how important interdisciplinary collaboration really is. Okay, particularly as a new flight instructor, I guess I'm more interested, I guess, in Gus's side of things when it comes to how do we actually teach, right? So I guess at the beginning of the presentation, we went through our Swiss cheese model, our good friend Jim Reason giving us one of the best tools that we have, especially in human factors and accident investigation. We talk about weather education, weather training, and then how do we actually certify our pilots. So I guess for someone who's taken, I don't know, maybe 10 check rides at this point, any pilot who's taken a check ride knows they just want to get through the check ride, right? We don't necessarily care about what the information is. We kind of just want to prep ourselves with some pre-ready-made meal answers to get us through the ride so that we can get that piece of plastic, right? Now, that's all well and good, but I think what today is really focusing on is the fact that this is not just information to pass a check ride, right? This is real-world stuff. And everything that we've kind of spoken about today is stuff that we're going to be using out in the real world. And I think what we've heard about today is how we're really making that move forward from just relaying information that we need to know on an exam versus actually being able to use that information firsthand. And yeah, I guess there's being in Embry-Riddle, that's what we really taught to do, is not, we're referred to a lot at Embry-Riddle as a kind of a factory that produces pilots. Sure, there's a lot of us. I guess we're probably one of the world's most renowned aviation institutions for sure. But what I really loved about my education here is that we're not taught to be kind of, although we sometimes are dubbed as robots to follow, if A then B, we really are actually taught how to be flexible and think a little bit outside the box. So that's what I really liked about today for sure. Yeah, that's my 2 cents on that, I guess. Alyssa?
Yeah, I just have a couple things to add. I am only a private pilot, so I don't have quite the experience that Jazz has, but I kind of have that experience of just the beginning piece of it, right? And I did all of my flight training in Southern California, where you have 360 days of sunshine and no clouds, and you can tell what the weather's going to be. You can tell if it's a no-go decision by walking outside and looking up. You walk outside, it's bright and sunny, we're going to go. You walk outside, it's super cloudy, it's going to stay that way all day. We're not going to go. And so that was interesting hearing Bob kind of talk earlier this morning about how I feel like I got so stuck in my, okay, well, what's going on right now and what do I need to focus on? And I remember when I got to the parts about the icing, it doesn't snow in Southern California. I'm never going to have to worry about that because my goal was never to be an airline pilot. That was never something that I wanted to do. I was flying for fun. I was flying because I enjoy the human factors and aviation side of it. And I kind of wanted to get that other experience for it to help make me a better human factors practitioner. And so that wasn't something I was focusing on. But here at Riddle, like we were saying, where most of these student pilots, like their goal is to make it to the airlines, to cargo, to corporate, even to the military. And so they're going to need to have this more robust knowledge of all of this information that they're going to have. And so me now as a human factors practitioner, trying to improve pilot training, trying to improve pilot performance, seeing ways that we can make training more effective, more cost effective, but still produce quality pilots, ensure that these students are getting the best education that they can to be the best pilots they can in this new age is going to be super important. And so it's interesting now as a human factors person to be able to try and look and work with instructors like Jazz to say, okay, well, what do you notice in your students? What are patterns that you're seeing repeated in these students? And then also be able to work with faculty, kind of like Gus was saying earlier, talking about different methods and different strategies for training these pilots and for training them. And how do we engage our students and how do we get them to care more about, well, this is just what I'm doing right now. This is the flight I'm doing right now. How do we get them to look at the weather en route, the weather where you get where you're going? How do we get them to think ahead more than just, okay, this is the weather at the airport right now, when, like someone was giving the example earlier of, oh, you looked at the weather at 5 a.m., but it's 8 a.m. now, right? It's been 3 hours. Like, how do we encourage our students to do that more? So yeah, that's just kind of all that I would have to add to that.
Great, thank you. We really appreciate that perspective. Do I have any other questions in the audience or online from the presentations that you've heard today? Anything that we would like to follow up on? This is your opportunity, so don't be shy.
Yeah, in the room especially, please don't be shy. We didn't give you tons and tons of time earlier today. Oh, Sarah's going to say something.
Yeah, thank you for all of your presentations. They're all really interesting and diverse range of topics covered. But one of the themes that I feel like came up several times.
And by the way, ladies and gentlemen, this is Dr. Sarah Strazzo from Embry-Riddle who's speaking.
Oh, I'm sorry. Yes, thank you, Matt. One of the themes that it seems like came up again in different contexts was trying to get students to consider the fact that the weather is going to change throughout their journey, right? So trying to get them to evaluate forecasts and consider how that's going to affect them at their origin, destination, and en route. So I'm not a pilot, but as someone who teaches pilots, how should we consider, what can we do in the classroom or training to better help students visualize those changes, which is hard to do, right? It's hard for us to do even as meteorologists, but how can you get someone who's not a trained meteorologist to think about the forecast and the potential evolution of the weather, especially as Matt was alluding to in like a probabilistic sense?
I just want to follow on with the some of the slides I was showing that what we're doing in the classroom for AVMET 2 in terms of data analytics, we do also look at seasonal and diurnal cycles of ceilings and fog statistics. So just a baseline climatology, they can see when the when is the fog frequency peaking during the day, and then I'm trying to get them to explain why is it decreasing, or when they're looking at the statistics from different parts of the country, what's the mental model behind the fog that's happening there? Is this an advective fog location? Is this a radiation fog location? So some of the kind of climatology does give them a baseline of the change, right? This is, if they start learning what the basic daily cycle looks like, then maybe when they're looking in a real-time environment, that will have some translation.
I'll go over that too. Talking about the dispatch side of things, at least from our airline ops command and control class, what I've done specifically for my class is it's called like pretty much a game that you're playing. You work out a script. So what we have is we have a scripted scenario that we run into, and it's a whole lab session where they look at weather that we introduce to them one at a time. So you're pretty much like running a real world situation, but you have control over it. And that's what we do in our lab, at least. So we run about 5 of them, and each one of them have like a different weather situation or maintenance situation. But since we're focusing more on weather, I'm trying to get them to think outside the box and go, instead of static, more real-time images, I would say.
So one thing I'd like doing when I'm teaching flight planning is at the very beginning, just have them look at the big picture and identify real quick, where's the good weather, where's the bad weather, and where's the bad weather moving in relationship to your flight. So before they even get down in the nitty gritty, they have an idea where that cold front's moving in. So if they got to divert, they're definitely not going to go south, for example, if it's coming in from the south or whatever. And I think that gives them a little bit of a big picture idea when they're doing that flight planning.
Yeah, I think obviously the most common theme that we've had so far today is just this ability to visualize the weather. Yeah, because weather is visual. It's not reading a METAR or TAF. Yes, you need to know how to do that, but it has to go way beyond that. And I know that's something that when I was in dispatch training, I really tried to do. My PowerPoint presentations would get gigantic because of just trying to put as much imagery in there as possible. But the problem is that you're dealing with students who are coming into this not having any of that background, right? And so you're all of a sudden bombarding them. They've been, they came from a regional airline or they got their certificate, 10, 15 years ago. And, half of them were lucky enough to be able to read a TAF to pass their test, right? And all of a sudden you're throwing enhanced infrared and water vapor satellite images at them in the classroom, and it can be overwhelming. And so I don't know if there's any, this issue of diverse backgrounds and how do we approach that. I think there was one who was presenting who mentioned starting from simple and moving to more complex. Was that you, Gus? You want to elaborate on that when it comes to like how could we apply that methodology when it comes to weather training? I know you're not a meteorologist, but this issue of you got a class of 20 people, and they have to learn weather, and they're all coming from different starting points. Like, where do you even start as an instructor?
Yeah, that's a great question, and it's an interesting one for me to answer as a. Well, you know the story. I'm not going to share it with the group, but as a pilot of weird things that are not meant to fly, and as a pilot of a controller of remote aircraft. But you know what I'm talking about. Those who know. Yeah, I think the idea of first, I'm going to take one step back here and associate the needed knowledge with the practice, and then create a competence building block where you go from simple to medium to complex. I think one example I could think of right off the bat here is what Tom mentioned, is start with the macro. And I would also encourage the development of intuition of weather, right? So even if you don't know all the processes that create mixed phase precipitation in low altitudes, you have an understanding of the general situation of like, well, there's warmer air aloft, this terminal area is dangerous, these situations. So starting from there into giving more detail. So instead of starting with that nice IR image, just start with what Sarah presented, the drawn situations where like, okay, this is the base situation, what's happening. What would you think? Like, what do you need to be thinking? And which goes to that point of learning to learn. So what are the questions you should be asking? And then once you move to the medium, more complex, you're like, well, if you are asking that question, by the way, there's this other product here that's the IR image that answers exactly that point that you didn't know before. And so it's giving the tools as needed, right, to the students. Tom, you seem like you were going to compliment. No? Okay.
Rick has a question.
Rick Curtis, Collins Aerospace. Kind of a question for the human factors folks. Use a medical analogy. When we have an ailment, we go to WebMD, right? They're going to tell us everything that's could be gone wrong, what's going to cure it, so on and so forth. Put that in the meteorology world. You get, especially, don't want to sound old, but this generation where they're more so reliant on technology that they're going to find all their answers from the Google machine, right? And so the point here is that one of the things I think that's important, I saw it in a 121 world in my past, is getting folks to know when to say when, meaning when am I going to be able to do what I can do by myself versus when can I go, when do I need to go ask somebody that knows more about this than I do? Because I'm only going to learn, be able to interpret so much on my own. And it's human nature. You're battling human nature. I don't want to go bother anybody. I don't want to, have to call 1-800 weather brief or whatever. I don't want to do that. That's extra work. And to try and break down some of those barriers of just knowing when to ask for help. I guess to me, that doesn't seem like it's very well promoted. It certainly wasn't my past world. So leave it at that.
Yeah, no, that's a very, very good question. And I think for me as a pilot, it all comes down to my confidence in my own knowledge, right? And I think I've been very lucky to have a lot of great instructors, but particularly in terms of the human factors world and all the classes that I've taken, what this all comes down to is decision making. And when we make a decision, there's three elements that are involved. There's information, there's your own knowledge, and then there's your experience. We know we can have either too much or too little experience. We need the knowledge to deal with that information, but how much is too much information or too little information? I think it's this question is going on to. Now, for me, I have a fairly good confidence in my knowledge, but I'm not at all afraid personally to ask for help when it comes to weather products. As a private pilot student in my early days of training, my instructors always encouraged me to use LIDOS, like 1-800-WX brief, in supplementation to my own knowledge. Now, if many of you here are meteorologists, I'm sure you guys would have watched the movie Twister, and you know that I'm not sure any of us here are quote unquote human barometers, as Bill was in the movie. We can all aspire to be. I certainly am not, but I am confident enough in my training in terms of weather to be able to spot certain patterns, and I think that's what we're looking at here. However, I think it's important for us as instructors and CFIs and professors to instill that guidance where, look, if your knowledge to interpret that information and your experience is limited, do not be afraid, because that can be the difference between life or death. And that is what I would put towards my students, is get rid of that fear of accessing another channel of information. You need to get over that fear of calling someone up on the telephone who's literally there to help you. So me as a CFI, that's what I would be saying to my students, I guess.
Yeah, and Josh touched perfectly on what I was going to talk about too, was like that mentorship and that encouragement from your CFIs, from your professors, from instructors, just even students who are older than you. When I was doing my private training, same thing. My first inclination was just, oh, this is all online. I'm just going to go to aviationweather.gov. I'm just going to do it all by myself. But I didn't have a complete, robust knowledge and understanding to even know what types of weather products to seek out. Sometimes my flight instructor was like, okay, you're going to call, 1-800-BRIEF. And I was like, well, why? And he was like, why would you not? Like, they're literally there to help you. That's their whole point. And so what he would have me do is like give myself the brief. I would do my briefing, look at aviationweather.gov, kind of tell him what I thought about, go through all of those things. And then he'd say, okay, let's call them. Let's see what they have to say. And then we'll compare between the two. We'll talk about it. We'll make that no-go decision. We'll talk about that. So having that encouragement from him was super helpful in order for him to say, no, it's okay to ask for help. Like, you don't know what you're doing. You don't have a lot of experience. That's fine. I'm going to teach you ways and tools that you can go seek out this information and try and give you as much help as possible, right? And even here with faculty, professors, staff, they'll talk about that all the time for things like office hours, right? They're like, come talk to us. Even if you don't have a specific question about what we're doing, just come talk to us. That's why we're here. That's why we do what we do. We love doing it. And so I think definitely, especially from a professor faculty side of it, especially from a CFI side of it, definitely instilling that, kind of making it part of the culture of education and of training, I think is going to be so helpful because that's how we learn, right? Because we're going to learn from those people. And then, when I'm trying to mentor someone and pass on information to them, I'm going to oftentimes take things that my instructors have given me, tools that they've given me, ways to seek out information and success, and kind of instill that. So I think it really starts at the top with that culture and that good mentoring relationship.
I just wanted to add something to that really quick. I'm sure our trusty Airbus captain at the back here is very familiar with crew resource management. And really I forget the AC 120-51A, whatever it is. I'm a nerd for those kind of things. But it says that crew resource management is using all available resources to come to a decision. Now, PIC discretion, you can make, the buck stops with you. But I think if we start filtering down the CRM concept down into everything, right, we get this notion of we need to incorporate everything and not to be afraid to incorporate everything and seek information if we need it. So it's all about not being afraid to do so.
Yeah, CRM, yeah, it's all about using all the tools at your disposal, right, to maximize situational awareness and to make safe decisions as a result. So I never really thought about CRM as a concept applied to weather training, but it makes a lot of sense. I almost would. Now I want more, Matt. I want a presentation on that from somebody because
Well, get to work.
we may sign you up to cover that topic in a future meeting, or tomorrow or the next day.
Yeah. Hey, I'd like to. I don't want to say push back because that's not quite the right word. But this morning, and I think it was Beth, somebody showed statistics that said that that a group of pilots were confident in their answer, which were frequently wrong. And so, Jazz, as you were saying, I understand, I'm confident in my answer. I just snapped right to that slide and thought, yeah, but you may be confident in a wrong answer. And similarly, and let me say philosophically, I agree with the CRM concept, and I think at the end of the day, over a long enough period of time, CRM produces better results than me just going out my own and doing my own thing because I'm highly experienced and reasonably competent, et cetera, et cetera. But there are some cases I think we can point to where group decision-making isn't as good as an individual. And unfortunately, in our case, we're talking potentially about life and death situations. So how do we navigate that particular area, which I didn't already have a head of whitish hair to make my hair go gray?
Yeah, that was actually something I was going to touch on earlier that I forgot about, but in the presentation that Beth was giving earlier, something like she had said, she was like, oh, I expect that when we get the 1-800 weather brief and the self-briefing, that's going to have the highest result, the highest accuracy, but that was not the case. The case was that if you did just the briefing by itself, that had the most accuracy. And so we were talking about, okay, well, why would that be? That doesn't make any sense. You're getting more information. Why would we have a lower score on that essentially? And so we were kind of talking back and forth about that, and going back to what Jazz had mentioned earlier about, you know, 3 components of kind of this human factors, the decision making, how having the information, he touched on it. He said, you can have too much information. You can have too little information. You can have too much information. And so I think that that is what kind of we were seeing when we were looking at that study, when we were looking at that data of there's so much information available, right? And at a certain point, you get so oversaturated and you're not able to utilize all this information. And when you get too overloaded by information, it can then become harder to pick out what's actually important, right? Something I was talking about with one of my professors was he used to do display designs like for the Navy for submarines. And it was so cluttered with information because they wanted to put every single piece of information on there because that's important, right? But sometimes having less information is better, and knowing when to have what information in certain types of situations is going to be better. And so that's something we're looking at right now as we're looking at like future flight deck design and the integration of AI, ML, even more digital displays in our aircraft. And this is kind of getting away from the weather a little bit, but even just in the display designs in general of what information are we presenting to the pilots and at what time, and what information are we trying to present to each pilot, right? Pilot flying versus pilot monitoring. There have been studies that look at where your attention is drawn and what you're looking at and what their roles and responsibilities are is going to dictate what kind of information is going to be most important to them and most helpful. And so I think you can apply that like to an aviation weather perspective too, right? There's a reason why we don't give you a map and you put every single piece of weather information on there, right? You have different charts for icing, for winds aloft, like you have all of these different, and it makes it kind of annoying, right? So you have to go find all these different ones, you have to know what you find, but then that ends at the end of the day, that makes it more helpful because you're able to prioritize what information is most important for what your mission is, for what your goal is, right? I said I did flight training in Southern California. It doesn't snow there. That's not really a problem. So I don't necessarily need to focus as much on those types of charts, whereas something like wind shear is going to be super, super important. I know, especially come the fall when the winds change and start coming from the inland versus off the ocean, right? Being aware of my contacts, having that experience like Jazz was talking about before, allows me to understand what information I should seek out, what I should prioritize, and what I shouldn't. So I hope that kind of answers your question. And if Jazz has anything to add.
To get to a part of the question and kind of rope all this in, and I promise, Nathan, I will not get into AI too much because that's our backup topic. But part of the conversation here, and part of your mention in the beginning of the question is, yeah, there are new tools coming out. Not only AI, but if we're looking at the FAA efforts with third-party weather providers. So new companies that are going to come up with their own algorithms that have their own nuance and all that. And you need to be in the know to know how to interpret all of that. And there will be a point where we'll not be able to do it. And obviously using assistance is, when used appropriate, helpful, right? I think all of us can be very glad that we don't have to shout, that we can do a hybrid meeting. So technology is not necessarily evil by itself. But all of that, at least in my perspective, makes the teaching of the basics more important. So the point that we were driving earlier of that intuition to even know what not to use, I think it becomes a bigger role of the educator. And so how do you sift through all this information? How do you know what to reject, right? Particularly when you're even considering marginal conditions in your region that you know that ASOS station with that wind direction is right behind the tower, and so I'm going to discard that information. So these things, the nuance that comes from great basic training, great intuition of what should be happening.
And I'm going to follow on a little bit on the confidence issue. I think sometimes if we oversimplify information in the education process, they think they've got it done. You can overly show the single cell thunderstorm model and, oh, good, it goes through these 3 stages. I'm done. I understand this. But if they don't have more of the spectrum of what can happen with thunderstorm activity, they could be confidently wrong, right? So, but it is a struggle that they only have so much time for weather, and you can only fit so much of the spectrum of actual weather in there. But I feel you have to, push as much as you can to give them the idea that it's not all one simple model. I think that leads to overconfidence, at least from my perspective.
Let's see, we've been talking a lot about the Matt Tucker. I've been talking a lot about the pre-flight briefings and everything else. And I trained, God, I've got more controllers I know still working in the NAS than I can count. But how do you teach the pilots to make the decision in the air that, hey, it's not going as forecasted. It's not looking right. I need to go ahead and set my butt down here. Or if the controller says, I would highly recommend you have a cup of coffee at an airport, it's probably a good hint that you should put it on the ground and wait it out. But how do you, I struggle teaching my students. It's like, hey, your plan's going down the tubes. You need to change without taking over for them, because it just kills confidence. But how do you teach the pilots to say, hey, it's time to make the proper decision, or go to plan B, C, D, even Z at sometimes?
So I can a little bit from my perspective. I'm more in the classroom with them, but where I see this come up sometimes is the looking at radar echoes, and of course red is bad, and they focus on the precipitation area. But of course, radar is just looking at the precipitation. It's not looking at the full picture of the weather. And I, try to get them to look at the gust front, because that's the thing that might be racing out towards the airport. They think they're getting to the airport in time because they're looking at the red thing, not the little fine line that's propagating out ahead of it. So, that's part of, spending the time with radar training to all the echoes that have a threat to them of some sort. So I try to incorporate it with looking at detailed gust fronts, because it's not just the red scary echo part, as an example. But I'm sure this crosses many different areas.
So Nathan, and you guys continue, but I just want to do a time check. It's almost 3 o'clock. I think what we thought might happen, my sense is happening. Do you agree?
Yeah. Continue.
So for the audience that doesn't know what that gobbledygook actually means, we speculated, we lamented the fact that we get into these wonderful discussions and then run into the time boundary. And then we have to cut them short, and we don't fully complete them. So because of the current DC situation, we ended up with a second 1-hour short session after this long session, which is scheduled to end right now. And we said, you know what, we're just going to leave it open. We've got something in our pocket in case we need to talk about an additional thing, which we're kind of veering into anyhow a little bit here. But I think this conversation is a good one, and I think we should continue it. So with your permission, I'm going to suggest that we just continue this conversation, let it go where it goes until it's time for free food and drink out in the lobby. Does that work? Okay. Work for you? Negative.
Sorry, I'm going to actually ask a quick question, if I may. Hi, everyone. Nick Christogelis, analyst at United, and ATC and Dispatch used to be Nathan's intern until January. I want to point out there was a slide in Michael's presentation when he was discussing the AI module that the #1 module that was built by those flight instructors when they kind of had to create your own time, if you will, was on en route decision making and en route weather. So that might be a gap that we're looking at here in general. So just something to point out that, this en route decision making, right, en route planning, it's a difficulty for maybe not just all of us. And it's something that I think we may need to improve on based upon those statistics. I don't know how big the population size was, but it's something to look into. It's not just about on the ground. It's about your ability to adapt in the air. And I think as someone, I come from a background of aviation management and meteorology at Purdue. I come from the non-cockpit side of things. When we're trying to forecast for the aviators, that's another thing that is a challenge for us, putting ourselves in the flight deck and understanding what you as a pilot, what you as an aviator are going through. So something to think about as we continue this conversation.
Yeah. I was just gonna comment on that. From the flight deck itself, I mean, obviously, we fly 172s and DA42s and stuff, and now our 172s have got all the bells and whistles. They're completely decked out, which is fantastic. But one thing that they do not have is a real-time weather radar. They do have, however, NEXRAD. Now, of any pilots in the room will have studied the latency period of the NEXRAD on the G1000. It's around about 15 minutes or so. Now, if you fly in Florida during the summer, I can tell you 15 minutes is way too long a time to have any sort of radar representation on that MFD, because things can change like that. And I'll tell you a little story in just 1 minute. I, for some ungodly reason, had my private and commercial pilot cross-country flights happen, all of them during summertime. My private pilot short and long cross countries, summertime. My commercial pilot long cross country solo, summertime. Now, as you know, you get these weather briefings. Well, we used to get them at, I don't know, 5, 6 o'clock in the morning. We go to the flight supervisor and they say, yeah, you look like you're good to go. Have fun. Don't kill yourself. Great. Now, it rarely ever goes like that. It's sort of clear in a million at 7 o'clock in the morning. You begin your flight. I, for my commercial pilot long cross country solo, went down to Marathon in the Florida Keys. Going down there was heavenly, apart from Miami Center being annoying. Sorry. But yeah, they were okay. No, they were helpful. It's fine. But they were. I have to say, when I told them I didn't want to fly 15 miles into the Everglades, they said, yeah, do you know what? That's probably not a good idea. So coming back from the Florida Keys was a different story, though, even though the forecast did tell us that actually we should be fine in terms of convective action for the day. That turned out to be completely wrong. Now, going past Palm Beach, back up on the way towards Daytona Beach, pop-up thunderstorm cells, you know how it works in Florida. I landed in Vero Beach, my second stop point, and I thought to myself, I don't know if I'm going to make it back to Daytona today, because I don't know how this weather is looking. Now, I'm going to go on to Gus's point of intuition. By that point, having received the education that we receive here at Embry-Riddle, by the time I was training to be a commercial pilot, you look at these cells, you look at these clouds, and you kind of get this human barometer sort of sense in yourself if you've lived in Florida for long enough to know what these things are doing. Now, that doesn't come from just being born with that. That comes from the education that we receive in terms of our weather training. And we've been taught to look at a lot of weather products, and we've been taught to look at a lot of weather trends and also be very cognizant of where these weather phenomena are occurring. And at that point, which is where I made the pilot in command discretionary decision to land and wait, was a good decision. But if I hadn't received that training that gave me that sort of intuition, I think a less experienced private pilot applicant would have continued and pressed on into less than ideal conditions. So learning the foundations, learning the basics to develop an intuition for a student or an applicant to be able to look at a cell, to be able to look at a cloud and think, is that just a cumulus cloud that's hanging out and having a good day, or is it a towering cumulus that's developing into something else? That's what we need to develop in our students and our applicants. And also NEXRAD, can you please make your latency time a bit less? That'll be great. Thanks.
I know we have some questions online that we probably should get to. I don't want to discount those online. So I'm going to go back up here to Walter Rogers. He has a question for Gus. Walter, are you in a position that you're able to unmute your mic and just you can give your question directly?
I don't know. Can you hear me?
Yes, we can.
Yes.
Okay. All I wanted to do was give a high five to Gus. I thought your PBL approach was excellent approach. And I think this is the route to effective aviation training, because it attacks what is needed, what's necessary to make the decisions, and then blossoms out into more detail with opportunities for talking about the technical aspects of references to that. So I simply just wanted to do that and ask if he would say more. That's all.
Thank you. Thank you. I don't know if you can see me in the camera, but I did the full high five. Thank you. Yeah, well, I'm wildly biased as the one that presented the idea here. But I'm actually excited to see that even without the proper name, which is just a detail, a lot of the educators that presented today have portions of it or their own flavor of it in their material. And I actually want to take a brief moment to pass the high five back online to Mike Dornike. Not only it's amazing, and he has a lot of these concepts implemented there. I guess I shouldn't even give him my example or worked on an example. Just said as like, now with the word Mike Dornike, can just have him be my example, because yeah, what he's doing there is really interesting. It exact to that point, particularly the idea of the quiz in the middle is that as a facilitator, as a guide of the problem solving, because you're trying to develop knowledge, that is exactly the cues that you want to give and that you want to prompt the students. And another super nod to him is that while he was finishing his explanation and doing the questions and answers, I was able to download it on my phone and do a test run, and it worked. So that is super cool, Mike. Congratulations.
I'll have to tell Elliot, he'll be very pleased.
All right, Wayne, okay. Yeah, we'll go back to the room first and then we'll go back online. Go ahead, Mike.
Right. Hi, Mike Forgetto, United Airlines Flight Dispatch Training. I kind of had one question, but I think it was kind of answered for Gus, but just going to say it anyway. So you were talking about the learn to fail, and you had the steps there, the fast gracefully and learn to recover. So for us, our program's long, maybe longer than some others. And what we've noticed is, especially at the end part, right, we spend a lot of times running scenarios. And all the scenarios are obviously not necessarily all emergencies, but they're non-normal type things, right? And then this is where they start getting stressed. And they're also getting near the end where they have a 3-day final test, basically oral and everything. And they get stressed to the point where they're all worried they're going to fail. And so now they're so focused on, well, I can't get this right because it's not something that normally happens. How do you help them? I don't want to say help them through it, but make sure that they're not so stressed about failing in a sense, whether it be just that portion or as a general for the class, to make sure that they are able to focus on what they need to focus to actually finish and get through.
That is an excellent question. I was talking to Beth earlier and it wasn't clear. So just to get it out there, if anyone was wondering, that 1989 first grader, it's me. So yeah, one thing I've done with students that has helped that, and it actually comes from my experience as a student, because with my challenges, with my disabilities, taking tests fast was always a challenge for me. And so I had a very binary situation with my grading early on, where either I aced a test or I wasn't even able to finish it. And so that was horrible. And I had horrible test anxieties. So one thing as a student that was good for me, and then later as an educator, I made sure to implement for my students, is bring that fear of the failure earlier on in the classroom homework environment, where I really, dial up the all the way on the exercises to things that are way more complex that I should be either teaching or testing, so that the test is actually a simpler version that they can do fast. And also as a grader and evaluator, by the time they hit the tests, I already know who knows in the classroom because of all the touch points they had before. So even if I have a situation where, let's say, a student got super nervous and wasn't able to perform, I can use discretion and talk to my department to say, well, we need to give the student a second chance. We need to maybe give a different exam to the student and work with those things. But in general, just by making the material much harder before the exam, by the time they get to the exam, they look at the exams and they say like, oh, this is easy. And that's kind of where I want to drive these students to where they're so competent at something that can look at something with confidence. So that goes also to the competence building. And so by the time they've done complex scenarios, open-ended scenarios, when they get to something that needs to fit a 50-minute exam window, they're like, okay, I know what he's talking about, and just they ace it ideally. Before we go online, Nathan, I want to switch gears here a little bit and talk about something within our community that is actually my expertise, which is the instrumentation and the measurements portion of it. I just want to throw this out there. It's just a comment because our awesome runner made a comment earlier about ASOS and that being the gold standard. First, I want to just say that as an instrumentation specialist and a measurement specialist, I
really don't know what I'm talking about.
No, it's all right. It's all right.
For the record, I should say that before everything I say. I do my thing, but yeah.
No, they are in a sense a standard. I see this phrase thrown out also with radiosondes. Oh, yeah, the gold standards of atmospheric profiling, and these technologies have known issues. They have their value. I don't want to throw shade at anyone or anything, but we need to, the point I really want to make is that weather products, weather instruments, they all have strengths and weaknesses. They have operational envelopes, and they have geographical variability, right? A certain model may work really well in the certain Great Plains, but not work as well in Florida, even if you're talking about the similar phenomena, right? So we got to, as educators and as pilots, yada yada, we all got to be mindful of letting people know about this nuance so that they can say, well, here when I'm flying back from Miami or whatever, this product tends to air this way. This product has this kind of bias. And so just that knowledge, I think, is something that we need to throw out there. And I just wanted to take this opportunity to say that.
Yeah, that's a big thing of mine is teaching the conditions and limitations of a particular weather product. So I wrote the EWINS manual at United Airlines, which I won't go into what that means, but it's basically our FAA approved document for our weather information system. And I show all the products that are our approved third-party products that we use for flight planning and operational control. And I actually list the conditions and limitations of those products in the manual. And so then our dispatch trainers, right, have some material that they can incorporate. And I've had them come to me and ask for material and say, hey, look at the EWINS manual. I give you the conditions and limitations. So we're actually inputting that into the training programs with dispatchers, especially. Now, I don't know if the pilots, quite frankly, get a lot of that. It's easier to do with dispatchers. I'm talking Part 121 now, right? Where dispatchers come into a classroom twice a year, right? Our pilots, they do come into a classroom or the training center once a year, but their program is so regimented that I don't know, at United, I don't believe they're getting a whole lot of real in-depth weather training. I don't know if Christian, if you want to, comment on the training. Like, do you get weather training that is more than just buttonology? Like, here's how to use the app and here's how to look up the products.
We do during continuing qual distance learning, which happens 3 times a year. We go basically take a pretty deep dive into the WSI to the EFB on the iPad, and we look at all the resources available to us on WSI. As far as like the, getting in the weeds about the limitations of individual sensors, and there's none of that really. But I do feel that it's actually pretty good for what we need to know. I mean, I will say we're spoiled by going into mostly big airports there's most days are VFR, and we have very capable equipment. And when I go in and it's not what's expected, it's a shock. It's like, I mean, are you kidding me? I'm having to go around right now. And that's when it's like, well, you don't see the runway. That's what you do. So that's what we did in that case. And then we got in the next time. But it's so rare that confirmation bias is really powerful in those moments. And you could see somebody just saying, well, it's not there now. Maybe I'll just slip a little under because it's going to be there. But
that's an interesting point. Thank you. So let's go back to the online. Wayne Sand, you had a question. How do you teach the right question to ask? That's a rather thought-provoking question. I'm not sure if anyone here wants to comment on it. But that was a question posed in the chat.
I'd like to answer that, but I don't know the right question to answer. And I do want you to, Matt Wandishin, poor guy's had his hand up like forever.
Really tired.
He's going to be like Popeye. His arm is going to be so big from being held.
Okay, well, then we'll go to Matt Wandishin. Matt, go ahead with your question.
All right, thanks. Yeah, no worries. I'm waiting. This is shifting gears a little bit from, it goes back to a comment Gus made maybe 20 minutes ago now, where you said something about waiting until the students need to know this bit of information before giving it to them. I think it was in the context of whatever it was, there was a whole bunch of information about the situation, weather information, and you just don't hit them with the IR imagery, I think maybe it was, until they know and even understand what that is. Which got me thinking, we've been working a bunch with, as a number of aviation products are moving to higher resolution. And these higher resolution products a lot of times have a lot of small scale variability, to the point where you look at some of these fields and you think, how can somebody make a decision based off these maps with all of this variability? And I wonder if the answer is along the lines of Gus's comment there, that not showing, when you're looking at a larger scale, don't show the small scale features. Start with the broader scale, and then zoom in to the regions of interest and add the additional details of that small scale information as you get into that, where you already have the context of what's happening in the larger scale to begin with. So I didn't phrase that as a question, but I think you see where the question's going.
Yeah, Matt, thank you for the question, and nice to see you. I would agree with that statement, and that's something within aviation and weather, at least when to address also the earlier question, at least when we're thinking about the distinction of pre and flight bag information, that you have a process of simplification of the information that is more actionable rather than fully detailed. And interestingly, my other hat as a developer of atmospheric observation, one of the things we were discussing yesterday is that you want to generate the information in its full detail, but in the form, particularly because it helps research, but in a form that you can change levels. One example that I gave yesterday is which I think, Matt, you've seen the Stormtrooper, the mixed phase precipitation unmanned system I've developed. And as it's classifying the composition of a certain precipitation environment, it actually looks and it gives a score and a composition of something. And so, well, it has this much characteristic of rain, this much characteristic of rain drizzle, and this much characteristic of, drizzle, for example. And the interesting part of doing that is that you can filter, like you're mentioning, either by what's the most prevalent phenomena that's happened, or what's the most hazardous. And this is not something I came up with. This is something that has been permeating some FAA products, some aviation weather service products as well. I've seen how they were doing. And so, yeah, I think that's the trajectory of applying presenting something that's simple and an overview, and then allowing you to do a deep dive with the control of levels, etc. Mike.
So I want to add a couple things. One thing, like looking at the HER resolution and all the speckly stuff, I agree. It's like, and just like NextRed, that's the snapshot in time, and those little things might be somewhere else. So do you give them the unfiltered? Do you, what do you do with that? Do you present it as is? Do you make it fuzzy? I've been, some people suggest make it a little less fuzzy, so it's not so precise as to say it's this little grid box right here. So there are issues with this, like it's false resolution. I would say I had an interesting data resolution issue come up in class because I was trying to get them to think about fog. And what type of fog was this? And somebody noticed there was a high pressure. So they had the conceptual model of this is radiation fog, high pressure, clear skies. But it was just one of these little H's that how many people have seen the H's show up all over the map because it's an analysis, and every little ridge, no matter how small it is, gets labeled. So this person had correctly this mental image, but the scale was all wrong. They had identified this little thing, but how can you blame them? The H is on the map, the thing we trained them for. So it was a dumb moment for me. It's like, why are we giving them such high resolution highs and lows? It seems very confusing. So yes, I think this resolution issue is important, and whether we filter some things or not.
Yeah, and just to continue and maybe bring the discussion back to the different levels of aviation that we're going to have to deal with, right? Once we have really short distance SUAS doing commercial operations, or let's say, I don't know if medium is the correct word, but I'm going to use it, medium distance AAM air taxi things. Once they change scales, right, they're coming in from, let's say, a rural or suburban environment to an urban environment, or they're leaving one urban environment, crossing rural area and entering another urban environment, they are going to have also a dynamic need for scale information. And so I think Matt brought up an interesting question of when do you give that information and how much do you give it? I don't have the answer fully, but I know it's going to be a need.
Matt Tucker again. For Gus, the whole the accuracy of the sensors has been a big issue since ASOS came online, and I can tell you I was the very first person to file a safety report on it. So because my site was the very first site to have it. One of the big problems with it has always been the ceiling. The visibility sensor has been rotten forever, and it's better, but still not where it should be. But the ceiling, you have 1 kilometer. At a major airport, especially as a controller, you're turning guys on final 8-10 miles out. What's happening at the airport may not mean anything to where these guys are in the pattern and everything else. And since you're also in the UAS realm, to me, that seems like a perfect kind of project to have UASs in certain parts of the area that would go up and take readings and then come back down every so often. So you had an accurate information for the terminal area, because what's happening on that little 10-foot by 10-foot patch of ground at wherever it happens to be at the airport, whether it's blocked or in a valley or whatever, isn't always accurate. And then has it been augmented? Is it are all the sensors operating? I mean, how many times do you see a dollar sign on a METAR? That's like, that's all the time anymore. So, and the next rads, the single site stuff is an issue, but if you go up in the panhandle, you've got more coverage than almost anywhere else in the country. So it's funny how that works, but also, do you guys teach the type of weather radar air traffic is using based on the airspace, if they're terminal or en route? Because there is a huge difference.
I don't believe so. That's something that actually I'm very interested in too, is really bridging this gap between pilots and ATC. I don't think there's enough of an understanding between our two schools of thought, even though we literally have to work with each other. But I don't believe so, no.
Just to add a comment to that question, series of questions, I guess. And if anyone's wondering, I did not give Matt Tucker any money to ask that question, but what you're saying, I'm again very biased because I'm one of the co-authors of a paper proposing a concept that's called the 3D mesonet, which is the idea of pairing UAS with mesonet towers, something we're trying to do with the Oklahoma mesonet for a couple of years, and we're working on all the technology, the flight restrictions, etc. But it would create that idea. And we actually did in September 2024 a very interesting experiment that Kevin was there, Lydia was there as well, in Tulsa, actually in Oklahoma in general, where we had 30-something UAS teams flying to 5,000 feet simultaneously, I think every hour, and looking at how these mesoscale weather patterns that were coming across from southwest Oklahoma towards the northeast, they would change as they roll through central Oklahoma into Tulsa, and understanding also the impacts of the skyline into turbulence, but also the impacts of urban heat island and all these fine detailed things. Regarding the general instrumentation and reliability of information, if you guys can go back, I'm going to make a plug back to ARAM. I think Matt's not going to mind. I think that's still a soft spot in your heart. But the last AMS ARAM conference, which is, for those that don't know, is Aviation, Range, and Aerospace Meteorology within the American Meteorological Society, had a couple of presentations, one by Randy Bass, which I think everyone here in the room may know who he is. Yeah, talking about how bad some of these instruments really are, and why they're bad and why they're historically bad. Not necessarily from a sensing perspective, but how the information gets propagated out of it autonomously, which is very interesting. But also in that same session, there was something that I find very interesting that I want to throw it out there to the community. Maybe this is a next FPAW topic. But as a community, I don't think we're very good. We don't do a good job at going back and looking how right we were, not only at forecasts, but there was a whole presentation on looking back at how TAFs performed. And so knowing and the performance level of these tools, I think is going to be really good for us as a community, because it reverts back to education, to that nuance, to all these things, and the work of the controllers and pilots, etc.
I want to follow up on the ceilings comment. I was fortunate to have a AvMet student that was a proficient Python programmer, and he tackled the ISAT data, which has atmospheric column cloud information, and we could get the bases and create faux METARs. Now, of course, it's a polar orbiter, and we just like matched when it was going over airport locations and matched the METAR to what we were getting from the ISAT. And sometimes we had good comparisons, but other times what's going on. but we had 3 swaths coming from the ISAT. You could see the variability across the airport, and then you're wondering, what is the soda straw of the salometer at the ASOS looking at? So there are deficiencies, but there's also people aren't really thinking about what's the observing strategy here. A soda straw instrument that's letting the clouds go by. I like telling my kids that, you know, you're not gonna, it could be almost half covered sky and you're not gonna have anything yet. Suddenly the first hint of cloud, and it might be almost broken cloud layer, and you're just start getting the hits. So people, you know, do we have to get into all the observing strategy issues so people know how to interpret that soda straw sensor? And then I just want to quickly go back to the question about, do we teach the ATC radar view? I don't have a bandwidth. I have to ask my ATC person, do they show ATC radar versus NexRad? But I do use some examples of incidents where the NTSB is showing the comparison of NexRad to ATC. So at least they have some introduction to that concept that it could look a lot different. So.
Yeah, there was an accident in Houston where the air traffic radar was showing level 6. NexRad wasn't showing anything. The pilot looked at his instrument or his iPad and said, "Oh, this is a nice hole," and went through it and wound up coming apart in the air. So that's kind of why I asked the question, is because there are times, especially depending on where you are, the air traffic radar may actually provide a much better picture than the NexRad's going to provide. And it has a higher update rate in some of those areas.
Yeah, I just wanted to add to that. Actually, one thing we are actually taught very well is to obviously use air traffic control as a resource. We're not told, we don't really taught what you guys use in terms of equipment, but we do know that whatever you guys see on your scope or your radar is more accurate than what we're seeing. And in my example of when I had to, you know, stay in Vero Beach for a little bit, that was something, a resource that I did use when I landed. I said to him, look, my NexRad is completely useless at this point, but not quite. But I said to him, like, look, is there any weather en route from here to Daytona Beach that I need to know? Because one, my iPad runs off Wi-Fi, not cellular, and my phone also runs off whatever 4Flight's got 15-minute delay of NexRad. Like, it's, I have nothing at my disposal at that point. And they were able to tell me what was going on. So to that extent, yes, we know that you guys have something further, but in terms of the specific equipment, no.
While I was listening today for much of the discussion, you know, we tried to improve the education and training of airmen. And we talked about content of the courses we teach. We talked about teaching methods and testing and evaluation. Where I'm going with this is, how do you define objectively whether you improved something or not? How do you define success? And I'm curious what our educators here have to say about that.
I don't want an NTSB report to have one of my students in it. And so that's what I'm going to consider success.
That's definitely a good point. Yep.
No, we don't do any sort of before and after. So they come in, they know very little about weather. And in the end, if they're able to complete a really nice weather flight plan and logically think through the steps, I consider that a win at that point.
Yeah, that's not to say that Tom's, you know, that Tom's tests are easy or anything like that, but that same student can then, from what I understand, and please online people correct me if I'm wrong, that same student can then go and take the test, fail the questions, all the weather questions, still score high enough to pass the test and get their license. So if that doesn't give you the heebie-jeebies, I don't know what does.
Yeah, I mean, that's a good point. I mean, at the risk of sounding humorous as well as a pilot, as I guess that my idea of success is that I've landed. I haven't broken anything on my airplane, and none of my passengers are injured either. But that's saying that loosely. But I think what Christian can attest to here in terms of the threat and error management aspect of flying is we do also debrief things. I'm sure you probably do debrief with your crew as well. And when it comes to us as CFIs, we debrief with students, and our CFIs debrief with us as students. And if there was a close call, we do know in aviation, you begin your career with a huge bank of luck and no experience, and you hope to fill up your experience before your bank of luck runs out. So that's the concept that I kind of like debriefing. Like if we did have a close call, why did the close call happen? Was it a lack of knowledge? Was it a lack of information? What it might be, but yeah, that'll be my viewpoint.
Yeah.
Yeah.
And it's again, also did not give Matthias any money to ask this question, but but I had the same question earlier, right? And in my outside of aviation weather experience, one of the things I've studied in education, in studying education itself, I was looking at what are the components of group learning and using it simulations, et cetera. And one of the things I did in the past was run the simulation. And I was talking to Beth earlier about this, and I was intended to talk to Tom about it, but we're going to bring it to the whole group now. But one of the things I did was I intentionally ran a simulation similar to what Beth shown, but in a different context in the beginning of the semester, because I wanted to see if they would perform poorly as you would expect. And then I ran the same simulation at the end of the semester to see what was the efficacy of my teaching in the middle. And it was good, and they learned something. It was great. But interesting enough, outside of learning from me, because in my case in particular, what also involved group work on the simulation, they also learned from each other a lot, which is great. And so I was actually going to propose to Tom to see if he wanted to run that test in his class. But I guess it's something we ought to be thinking about.
Sure, I'd be happy to do something. I think that sounds very interesting, actually. Can I mention something? One weakness I find in aviation weather education, I feel like, is we can show them all the maps in the world, show them everything, but when they get in that cockpit, and we kind of alluded to this a little bit, how do they know what they're seeing? How do they relate that to the hazards? And one of the biggest ones is VFR into IMC, and that's the highest accident rate year after year for private pilots. And if you are lucky enough to find one that survived that, the interviews all show, they say, we didn't know it was bad until it was too bad. So how can we simulate that? And I think augmented reality may be the answer to this, where we can put them in headsets and have them and simulate the weather getting bad, running into poor visibility, and see at what point, for example, they decide, nope, I got to turn around and go back. It's gotten too dangerous. Or recognizing a squall line coming back, right? So they know there's some weather coming in, and they think they're going to avoid it. What's that look like from the pilot's perspective, not just from a satellite view or radar view? What's it look like looking out the window so pilots can make those decisions? And I really think augmented reality is going to help with this. I just haven't played with that enough yet.
Just to follow on that comment, I teach a first level course, and part of that is I make them go out and take pictures of clouds, which you'd think they'd be good at. They're good at taking pictures, let's put it that way. But identifying what kind of clouds they are, you think would be, what's out the window kind of experience, right? So, and some of them get the idea and can start up properly identifying them. And then from that, hopefully they understand some of the hazards associated with them, but but then again, there's more complicated cloud patterns, right? Sometimes it's easy to see an isolated thunderstorm, but what about embedded thunderstorms? You really can't see that. So there's simple views that might help them learn about cloud types, but then we get into the murky nature of fixed cloud types and stuff like that. So That makes it more challenging to give them that, like I said, the real spectrum of what they're going to see out the window.
Yeah, and I would like to volunteer a future presentation as well from, well, if possible. I should caveat that by Cliff Johnson from the FAA, if it's ever possible for him to share the work he's doing exactly to Tom's question. Because last FAA, we were at the Tech Center and was an amazing, not FAA, let's FPAW. We were at the FAA Tech Center and was an amazing experience. And interestingly enough, I had the experience of being in the cockpit on the simulated helicopter, and Matt Wanderson gracefully asked Cliff to make it the worst possible weather while I was flying in a valley in Switzerland. And and I can tell you, it was because of the environment was so well done. It was completely disorienting, and I ended up crashing the first when they made it really bad, and I was clear day into really bad, and that happened. So I think Cliff could give us some really cool insight into that. He has excellent research in that.
So Nathan, you got a bunch of chatter going online here. I don't know if you want to try sifting any of that out. I did actually want to, Randy Bass's first comment in here mirrors something, Gus, that I was thinking when you made a statement that I interpreted as, these are my words now, I interpreted as individual components of an ASOS or AWOS system don't work as well in certain parts of the country as others. That's how I interpreted your words. Randy also pushed back on differences on individual sensors not being accurate in their measurements, but he did agree, and I'm guessing this is what you were saying, that the representativeness of that information relative to the larger area differs when you go around different parts of the country. As well, or so go back to the beginning, the first thing you said then about
well,
what did you mean?
So so there's two parts. I'm gonna adjust the first part. Sometimes and man, that's a game of telephone because I'm talking about Randy's presentations. So I'm going to talk first about my.
And he's online, and we're going to let him unmute here and come through the phone.
No, we'll keep him on mute and just say whatever we want about what he said. No, I'm kidding. So first, what I was talking about, it's a mix of Scott Landalt's work and Randy's work. And so the first part, the sensors, right? The sensors in general are pretty good. There are some known weather phenomena that they're known to fail. I think Scott's work with freezing drizzle and other kind of freezing precipitation is very interesting. Particularly, he has a work where he was comparing ASOS stations that are, I think, man, I'm butchering. Sorry, Scott, if you're there. I think they were 5 or 10 nautical miles apart, but one was in the US, the other one was in Canada. The other one was in Canada, they processed the information slightly different. And so they were under the same weather pattern, but they were showing completely different weather conditions. And so that happens, right? Second part of it is, even if the sensor gets the information correctly, right, there's a twofold, and that comes from Randy. The first is I'm accurately measuring a non-descriptive information. And one example that Randy used was, okay, you put an ASOS station there, and 20 years later, a big old tree grows and shades your solar radiation sensor, so that the sensor is accurate in measuring that shade, but the shade is not representative of the airport at all. So that happens. But then there's the element, okay, everything, the sensor is okay, the installation is okay, and I'm representing really well that straw, but not necessarily the whole region, the terminal area. And so there are 3 levels to the issue.
So I want to follow up on that from my work way back in the atmospheric radiation measurement program and trying to get clouds right. The aerosol cloud boundary is a difficult one. And now you have to start talking about the ugly aerosols and hydrophobic aerosols and, that gets complicated, right? And so sensing systems have, where is that boundary? And they might not give you the same answer to different systems. So I could see that being a sensor issue. But think about this, then we want to translate to the aviators, because I see this a lot. What is the magic dew point depression that you start worrying about fog or cloud? And I think, who has that number? Just a quiz. Is there any, a lot of times people pull out 3 out of a hat. There's a 3. Once it gets 3 and less, you start worrying about it's getting humid, right? You might get clouds and stuff like that. I asked some students, they'll go 0. It has to be temperature equal to dew point. Of course, we do we do test this out in class. We do hits, miss, false alarm, correct negatives, and show how bad using just some simple metric like the dew point depression is. But then we haven't got into how could this vary from the Smoky Mountains with completely different aerosols than a marine location with salt nuclei versus middle of Oklahoma and continental nuclei. So, there are microphysics that matter and can change how we interpret even a